Hello, everybody. I'm using the standard microphone from the laptop that I'm streaming from right now, so my voice is not going to get any better than this. Welcome to Rocket Secure 4. Um, their first speaker today is Fernando Tomlinson. He spoke and did a class at B-Sides last year in Huntsville, and if you missed that, you'll probably get a chance in the future to take one of his classes. They are definitely worth it. He is a modern day Davy Crockett as far as living off the land, and he does red team, blue team, and has some cool stories and examples to share. I'm going to turn it over to him. Fernando, if you give me just 1 second to make sure that your mic moves on over, and can you say hello?
Hey, good morning. Can you hear me?
It's like you're coming through.
Okay. Hey, good morning, everyone. Welcome to Alter Ego, Defensive and Offensive Use of Capabilities. And specifically, we're going to be talking about PowerShell. Thanks for having me on Rocket Secure. I'm an Alabama native. So anytime I can definitely get a chance to do anything with Alabama, I look forward to the opportunity. Roll Tide. Hey, so a little bit about myself. Been with the DoD for been with the DoD for about 19 years now. Currently do forensics and malware analysis for Army Cyber Command. Previous to that, I was leading a cyber operations center, and we did kind of a little bit of everything. Really, purple team in nature, a little blue, a little red, a little bit of everything, and it was truly amazing. I'm also a cybersecurity adjunct professor at a college where I teach Python and digital forensics. I'm an avid lover of the language of PowerShell. Co-authored a book. Make no proceeds from the book. All the proceeds that we do get from it, it goes to underprivileged, underrepresented individuals trying to get their start in cybersecurity. So I can sympathize with that because I've been there, and I hope that it's helping other people get a start. Number of other platforms that I've been a part of, and my presence on the interwebs there, if you will. Okay, so loosely based, this is kind of the agenda. We got a lot of stuff here, and there's so many things we could talk about when it comes to this language. And I'm trying to give you some good stuff to kind of walk away with, to kind of scratch your itch, satisfy some curiosity, and maybe spark something for you to want to get a little bit deeper in this. So PowerShell itself was introduced in 2006. It itself is implemented as an engine. It is compiled in .NET. So .NET is a Microsoft thing, kind of a framework in which allows for interoperability of building of platforms and applications. PowerShell itself, though, when we look at it, we're accustomed to an executable, well, PowerShell.exe or PowerShell _ISC. Well, neither one of those are actually PowerShells. They are just hosting engines that allow us to interact with the system.management.automation.dll binary, which is truly PowerShell. It is a scripting language. Some would call it a programming language. It is super inherent to Windows, and that's one of the things that makes it great. Now, we also have the ability to do some remote management, utilizing it from the perspective of almost like an SSH-like capability. Or we also have the ability to do remote management from the perspective of one machine to many all at the same time. PowerShell is really great because if we wanted to call it a programming language, it's object oriented, right? So what does that mean? So if I was working with Bash right now and I wanted to get a netstat and get specific items out of there, I would find myself maybe using a little bit of grep, but maybe some sed, awk, maybe some cut. And then if I was off a little bit, I would find myself kind of finagling that all over again. But with PowerShell, because it's object oriented, we have properties that we can actually select, and those properties have specific methods associated with them. So when we're working with items in PowerShell, they're full objects, and that's great. Our functionality is largely built upon these commandlets, things that are kind of inherent to the language, pre-compiled to allow us to do certain functionality. We have functions that we can build on our own, reusable chunks of codes. We have other scripts and modules, and then we can also use native commands. So it's not one of those things that if you start using the language, you have to divest yourself of other things. Now, what are the things that makes it great for the blue team? Well, starting with Windows 7, 2008 R2 and above, it was built in. It's already there. I don't know about you. When I go to a get together at a friend's house, I love it when they say, "Hey, Fernando, don't worry about bringing anything. Just show up. We already got everything I need." And from a blue team perspective, this is where this becomes helpful. Specifically, if you're an outside entity that does incident response and finds yourself going into a number of different environments, and some of those environments are keen on you bringing different appliances and other tools, while others are not necessarily keen on that fact. So if you can utilize what's already there, it's a win-win. PowerShell has access to the APIs on the system, so we can utilize a lot of those items that are available to us. And if we got to the point of building some type of implant or an EDR, if you will, we can encrypt that traffic so we can ensure we have some integrity across the wire. If people were trying to abuse it, PowerShell has come a long way in the sense of being able to highlight that abuse. And again, we can build some form of EDR to be able to really amplify and show items of interest from a blue team perspective. Now, some of the things that made it great from a blue team perspective is also kind of what makes it great from a red team perspective, namely the first three, right? So red team guy, he doesn't have to bring his whole toolkit with him, some customized thing. He can just utilize what's already on the system. And if done right, he starts to blend in with normalized traffic that's on the machine, especially when you look at commercial EDRs that are out there today, something like, actually, I won't name the EDR, but some EDRs that are commercially available today, they utilize PowerShell scripts when you task the machines to do things. So from a red team perspective, since there's already so much PowerShell being thrown around, you could just jump in there and just blend right on in. We also have the ability to bypass detections, right? So as a signature or heuristic is developed, if I'm developing this code, I can then alter it to bypass whatever those detections are. What's great about this too is some people don't even upgrade their PowerShell versions to the newest, latest, and greatest. And because of that, older versions lack some security in it. So we can get on a system that falls in the scope of that, we can then take advantage of it. And then also I mentioned that the newer versions contain some enhanced logging, but if that's not configured, then it's a good day for a red teamer. Now, so as we talk about the red team aspect and blue team, you're like, okay, yeah, I see some coverage, but I also see some difference. And it's not just necessarily that, because this is a task management language, and it was really made for system administrators. But the landscape is really shared amongst all three of the entities, right? There's some some duplication of efforts or ability, but largely speaking, it's all useful for each one of them. And it's not just them, really. It's for other things as well. So if you have a Tesla, somebody wrote a module that allows you to control your Tesla. Now, I don't have one, but I'm super pumped up and excited that they took the time to do this. But that starts to highlight the granularity, if you will, of the language and its ability to be useful for other things other than the three things we just mentioned. So yes, I'm dead serious about that. So if you want to Google it, it is a thing. It's out there. All right, so let's look at how do we use this from a blue team perspective, right? Not an all-inclusive list, but a couple of things to kind of get the juices flowing. The first thing, hashes, right? If you're doing blue team type activity, hashing is a key thing, right? Namely, from an IOC perspective, you want to be able to validate the integrity of an item to make sure it hasn't been altered in the validity of it. So largely speaking, high level, we have an input. In this case, we'll take a binary. There's a process. This is going to be an algorithm or a function based upon the algorithm itself. And then there's an output, that one-way computation. And if we can validate, or we can determine that on one hand, ship or move a file and do something else with it, and then validate that it is the same, then we'll rest assured that nothing has been altered. Now, there are a long laundry list of well-known hashes on a general Microsoft machine. How do we get after validating them? Well, one might look to hash the whole machine or hash everything on there, but we have a better way. So we can do something like this, right? Just starting off with hashes. we can get file hash, specify a binary, and return that hash. By default, it's going to do SHA-256. On the second example, you see how we've changed that to MD5. If we want to do a whole directory of sorts, we can just get a directory listing and pipe it to get file hash, and again, specify that algorithm. So getting after it, this laundry list of hashes on a machine. Well, National Software Reference Library publishes well-known hashes, so we can utilize that, put it in the dictionary of sorts. That still could be a little bit time intensive if we're going to ship all hashes to this library to validate them. All right. We would look to do it across the disk. That's going to be resource intensive. So a recommendation, let's focus on processes that are running or just tailored, specified based upon the application and the environment in which we're operating in. So then we have something like this, roughly 10 lines of code. We're going to do this on running processes. If malware makes it to disk and nothing highlights that it is malicious in nature, then I want to at least capture it when it runs and it executes. So with 10 lines of code, we can hash the running processes of sorts. And then we could do something like this, right? Now, we're utilizing what we have available. We utilize VirusTotal. We're not going to submit the actual sample. We're just going to look at the hash. They have a free API. That API comes with limitations, 4 requests per minute, right? And then we see the daily and monthly quota. So took a little bit of PowerShell code and came up with a method to automatically hash the running processes and submit unique hashes to VirusTotal. And then as I've already seen them, they then go in a dictionary or a library or a list, if you will, of sorts. So now I'm not hashing every one of them, but it's done in a controlled manner. And because we can only do 4 per minute, every 15 seconds, it submits one. So you'll see the number of hashes right out the gate that's being submitted at this time is 2, gives you an estimation based upon the limit per minute. And then we see those 2 hashes. You'll notice that it doesn't necessarily have to be MD5 or SHA-1. It could be any variation of it. And what we get back are those 50-some AVs, the versions, whether that sample is detected. And if it is, it'll list the results in the sense of what it knows it is, the AV signature, the date it was last updated, and the hash itself. So looking at it from a list, a table perspective, we see that. And right out the gate, I see a number of them that are false, but I see some that are true. And because I see some that are true, now my curiosity is sparked a little bit more. So utilizing something like VirusTotal, we can then tailor our hash search and get something to a manageable list of things that we can then go after. And we can automate that. The other great thing from a defense perspective is getting a list of running processes and getting a net stat, right? So one of the first 2 things you might look to do, tell me what processes are running, tell me what connections I have, and what ports are bound. From a PowerShell perspective, we can do process lists with get process, and we see a sample of that output. We can also do a net stat with get net TCP connection, and we see a example of that output. Now, the problem with that is I might look in my net stat and I might see a binary that's communicating, or I'm sorry, a connection that has a binary tied to it that's communicating, and I get the ID off of it. And then I find myself trying to transition over to get process, look for the ID so I can then validate whatever binary that is. And really what I'm trying to say is there's a lot of swivel chairing back and forth between views. So I thought about it from this perspective, right? Reese's cups with Reese's pieces, you put it together and you get pure goodness, right? Like I wish I would have came up with that. So taking that same mindset and construct, ended up coming up with verbose process, where we really commingle the process list and net stat together. This is going to return a clearer picture, definitely reduces the oversight. As I'm looking at net stat and I see a PID of interest, I swivel chair back over and I'm like, man, was that a PID of 4114 or was that 4115? What was that PID? Well, let me swivel back over, right? And then we can export this to CSV, XML, JSON, whatever we want. Why? Because we might do some tactical analysis on one machine, but we might want to actually get that into our SIEM so we can have some form of a larger picture, if you will. So this is a sample output. So we have local IP, the local port, the destination IP and port. And this is two different entries, if you will. And then for each one of them, we have not only the name of the executable, but that process ID, where it's running from on disk, the hash, and any command line argument. Additionally, we have the parent process of it, the parent process PID, where that process is running from on disk, and the process hash as well. So for each one of the items listed, we're going to get all that enriched data in one view. So that's going to reduce our ability to make any mistakes. Automated profile is something that came up with for disk forensics. So at current 500 gig disk, you could do some form of tactical, very quick triage analysis in about 4 minutes. It's going to produce a report for you so you can kind of have a quick synopsis about it. Here are a number of things that Automated Profile is going to retrieve from you. And largely speaking, it's going to go after the things you most likely would go after during a disk analysis, right? And I really came up with this because there was a incident I was on a few years ago in which it was high profile. And as I found something, my boss is like, "Hey, Nando, what's next? What else do you have? Did you find something else? Hey, do you have this?" And the more and more he was asking about that, because he was getting pressure, the less and less I was able to concentrate on it. And same thing with my team. So we came up with this. So now we can get a preliminary report with the things we would always look for, be able to provide that to my boss. He would then be satisfied for a moment in time. That would allow us to go deeper. So within 4 to 5 minutes, we could have some initial triage analysis done on a disk image. All right. So from a PowerShell perspective, when running the script, I'm just feeding it a drive letter for where I have that image mounted as read only. And then I get some type of indication as to how much of it has been complete. Now, this report is going to come back in a flat text perspective, but it's formatted rather well. Again, it goes after the things that we would always look for, allowing us time to then go deeper, right? Automate the boring stuff, automate the repetitive stuff. Okay, so from a DNS perspective, right? Let's talk about the DNS process, actually. So if a user is on their system and they try to go to google.com, the first thing that's going to happen is the local system is going to check its host file to see if there's an entry in there, i.e. I could say google.com is at this IP. So now it doesn't actually need to resolve DNS. If nothing's there, it will check the local DNS cache. Hey, have we already looked for this domain before and we have this in our cache? And again, that cache is going to be stored on the system for a short period of time. If it's not there, then it's going to query its configured DNS server. If that DNS server is then going to check its cache, same thing, right? Hey, is this something that we've already got the resolution for and we have this? And if not, it's then going to check to see if it's authoritative for that domain. If it's authoritative for that domain, it will return the IP. If it's not, it will utilize root hints, i.e. next DNS servers above it, or it will just forward it to whatever DNS server it's configured to forward to. So from a defensive perspective, we might find a domain in which we want to prevent our systems to go to, right? And going through this process, we got 2 places that we can do that, right? Right in the system, the host file, put that domain in, put loopback IP, and now when the system tries to resolve that domain, it's not going to get anywhere. That kind of works well for 1, 2, maybe 3 machines. But when I got a domain full of machines, nobody's going to do that. So then I'll take it a step higher and I'll do it at my DNS server. I'll say I'm authoritative for the domain that I don't want my systems going to. And by doing so, I'll create that zone record, put in quad zeros, loopback, what have you, and I'm essentially sinkholing that domain. Sinkholing? Yeah, sinkholing. So let's use this picture. I'm in a car off to the left, off the screen here. I'm trying to get to those buildings to the right, top right, if you will. There's a gigantic sinkhole in the ground that in theory is preventing me from making it to where I want to go. Never mind, there's a little bit of space on the side that I probably can get around, right? So we're essentially preventing communication to those domains by sinkholing them and not allowing them to get there. Now, if the actor is switching from domains to IPs, different ball game. But with domains, we're good to go. So how does this work for us? Well, you'll execute the code, invoke Syncode domain. You can either download a blacklist domains list off the web from a reputable place, or you can provide it your own custom domains that you want to block. It will then create a for lookup zone for those domains. It will create an A record for a quad 0, loopback, whatever you want. And if you're concerned about IPv6, then we can absolutely configure it for quad A records. All right. So off to the left, I see a number of forward lookup zones that I've created. The one that's highlighted is 02quad9.com. And off to the right, I'm now going to say I'm authoritative for it, and here is the IP associated with it. So if anybody in my domain is trying to get to that domain or any subdomain of it, I'm going to return quad zeros as the IP, and then that machine's not going to be able to communicate with it. Again, if we get to the point of using IP addresses, then the game is now changed and we need to go back with something else. But from a PowerShell perspective, we're able to get after mitigations. Again, all using something inherent to the machine. All right, parts and event logs. With PowerShell, we got two different ways to do that. We have get event log that allows us to get classic logs, if you will, the main stuff, system security, application. And then we have get when event. That's going to not only allow us to get classic logs, but the event tracing logs. So that's things like, you know, SMB shares, PowerShell, WMI, all the stuff that came about with Vista and newer. The big difference here is get when event not only is going to allow us to get more logs, but it also allows us to read offline EVTX files. So if I'm here in Augusta, Georgia, right, wishing I was in Alabama, and one of you were working with an event log, and you're like, hey, Nando, there's some shady stuff going on here. Could you take a look at it? You could absolutely send that EVTX file, and then I'd be able to read it back into PowerShell, just like I would be able to import it into Event Viewer, but I'd be able to utilize PowerShell to query it. All right, same thing if I had something I wanted to get to you. Now, another big difference is where the filtering is done. So with get event log, we absolutely can query remote systems, right? But that filtering is going to be done locally, whereas when we utilize get when event, that filtering is going to be done on a remote machine. So if I'm doing this in a domain, I need to be cognizant of that, especially when I need to understand processing and power and what I'm doing on remote machines and what that implication could have there. So something like this, 4688 is an event ID that's process creation, not enabled by default, but arguably one of the better logs within Windows. When I query that log, notice what I get back. I get this table. This table isn't essentially telling me anything other than I have 20, 30, 40, whatever number of events that meet the category of a new process is created. From an analyst, this isn't usable. What I could do is select every property available or expand that log, if you will. And now I get the guts, if you will, of that log. Now, the properties listed for this are message, ID, version, qualifiers, level, task, and there's a number of other ones. But looking at this screenshot, the bulk of what I need and I care about is in the message field. Really what I care about is stuff like, I don't know, the account name, maybe the process ID, the new process ID, right? The parent, stuff like that. But those aren't raw properties that I can just call upon as is. So how do I get that? Well, these properties also have properties. I call them sub-properties. And when I identify their position, their index, well, I can query for those things right out the gate on my own. And then I'm able to produce a tailored list or tailored table of what I care about. Hence, we have time created, process, command line, account, creator. Out of everything in this message field, those were the things that I personally, as an analyst, cared to see. So I was able to do my code in such a way where I can return just that. Now, I take the time to do it once, and I'm able to use it many times. So the next time I'm dealing with a set of 4688 logs, I've already created a parser to return those results in a way that makes sense for me, the analyst, right? Build once, use many times. And in this case, I see stuff like Netcat being run on quad 4s, right? I might have missed that because of the way the data was being presented to me. And an adversary would take advantage of that, right? They would certainly be happy with that. Now, I could also utilize something like Outgrid View and pipe my now filtered list in here. And if you're not familiar with Outgrid View, it's like an Excel-like feature within PowerShell, right? If you don't need to use this, or I don't have a desire because you have a scene, then that's all fine and dandy. This really helps out with the tactical analysis, if you will. But again, built into PowerShell. You can't beat this, all right? All right, so PowerShell Rapid Response. Again, there's a number of EDRs out there, and they all do great stuff. PowerShell Rapid Response is something I developed to be able to go after the enterprise, quick identification of anomalies, retrieves a number of items of interest. This is more of a modular built capability. I say that because right now, while there's 20 items that we can go after, we can absolutely build more modules to then add to it. This utilizes a pull method. So I only get what's happening when I tell the server to go out to clients and retrieve the data. I don't get them in near real time, like a push based upon the events happening. So there's a little bit that I'm taking as a risk here. This data is going to come back in a number of formats. I can put it, actually one of the formats is it's going to be put into a SQL DB. I can hook that up to a front end if I wanted to have a better correlation or some type of visual aspect. And this utilizes a network logon, so I don't have to worry about things like Mimikatz coming in and taking advantage of my use of my EDR here. So a couple of things that we get after, and again, these are all essentially modules. So if you don't like that it retrieves system information, you can take that module out. If there's something else that you wanted to retrieve that I don't currently do, well, you could certainly build it and kind of continue on with it. I think it's best to think of it kind of like a Metasploit-like capability, if you will, for a defensive use, right? All right, so let's demo this. All right, so out the gate, when we run this, we can specify different options. With option 1, we're going to get all the domain computers, right? It's going to query AD. We could import a list off of a flat file. We can absolutely input a computer or an IP manually, or we could just run off the local system. I'm going to do this as option 3. So we'll input a machine. I can do a CIDR notation or specify individual machines, and we'll specify an individual, right? So this is now sending the command out there or sending the tasking out to actually execute this stuff. And then it's going to retrieve that data back. Once it gets back, it's then going to be imported into a database. There's threading associated with this. So it's not like I have to wait for one to get done before the next one gets done of sorts. Let's look at the structure. All right, so when it comes back for each run that you do, it comes back in its own directory, right? Based upon the date and the time. Again, where you have the ability to specify what we want to come back as, CSV is going to be our default option. The database itself, as each data set is coming back, it's going to get added to the overall SQL database. Now, that database itself, we can open it up with something like a SQLite viewer, import it in with whatever other database capability you enjoy using or have or what have you. Now, I'm going to go in here and open this up. I shouldn't, because I should wait till it gets done. But for the sake of time, I'm going to try to go through this a little bit quicker. right? So for each one of those CSVs, each one of those modules, if you will, there comes back with a table within this database. So then I'd be able to do my queries, do my analysis, get a better understanding of what's going on with those machines or that machine that I'm working with. Right. So again, it's going to query the machines. It's going to bring that data back. Once it gets back, it's going to commit it to the database. Once I have that, I can kind of continue on with my analysis and do whatever my task is. And it's nearing the end of its pull, and then we'll see where it gets to the point where it's going to actually start importing. So now that it's importing, you'll see very quickly a item comes up as a temp thing, and then it commits it to the database. I'm going to go ahead and stop it since it's already done. All right, but that's POSH-R2, PowerShell Rapid Response. All right, so also have invoke suspend process. Essentially, this attaches a debugger to a process. It suspends and resumes the process based upon the process ID. And why is this a thing, right? Because if ransomware is running, I want to be able to suspend that process, be able to possibly get the keys out of it. Maybe a binary is injected into a critical running process, and I don't want to terminate it, but I don't need it running, if you will. So I will just suspend it or certain aspects of it. Okay, so let's look at this. All right, so I'm gonna run demo beacon. Demo beacon, when ran, the only thing it does is return an integer and saying it's beacon home. I'm gonna come over here and we'll get the process ID of that process. We see the process ID is 12060. I'm going to come over here and we'll run invoke process suspend. We got one parameter that's going to be ID, and we'll notice once we've attached the debugger to it, the process is still running, but we've essentially paused it, suspended it, if you will. Right. So again, if it's critical, we're not in a point of terminating it and of essentially messing up something else in our session or in our machine. Now, when we've done our analysis or we've done whatever it is that we desire to do, we could come back in here and we could resume that process. And conversely, we still have the ID parameter, but then we're going to specify that ID again that we need to resume. Once we do that, the debugger is removed and it continues on. All right, invoke fail to ban. So fail to ban, an amazing program, right? If you have Linux-based servers, Nix-based servers, public-facing, or just period, fail to ban allows you to monitor for failed logons, and once the threshold is met, it will essentially jail that IP or system that's trying to communicate with it. So that way you don't have somebody trying to brute force your machine and just doing it all times of the day, all day long, right? And you can jail them or quarantine them, whatever, for a period of a couple seconds, minutes, hours, months, whatever it is, right? All configurable. Well, conversely, when you look at having the same capability from a Windows perspective, I seen a gap here. There's a couple that are out there, but they didn't quite do what I needed it to do, so I ended up making my own. Configurable threshold based upon IP logon, IP whitelisting, again, taken straight from the original fail to ban. Same thing with the ban timeout. So the IPs that I block, they get committed to the event log. As an attacker, people will try to clear their tracks. I like to get my stuff committed to the event log. I also like to hurry up and ship my stuff to a scene of sorts, right? So that's something we added. Block whitelisted IPs. We add those things to a queryable database again. So now I can add some type of front end or have an ability to make queries based upon my desire. And if there's any time where I just need to let everybody out of jail, quote unquote, you could just remove all banned IPs. Well, let's walk through it from this perspective. So I got the attacker guy on the left. I got the good guy on the right, if you will. The attacker tries to log in, admin with a password of 123, tries the same thing with a password of 456. He just keeps going. And finally, he gets lucky. He gains access to the target And unbeknownst to the guy on the right who's still happy, he doesn't realize he now has a friend who's in his system with him. When we utilize invoke fail to ban, if we have a threshold of 3, after 3, that guy, that person, that malicious actor is no longer going to be able to interact with us in any way. We'll be able to then get that entry out the event log. Maybe that becomes an alert on my SIEM of sorts. I'm getting visibility for internet-facing things that I may or may not have before. Okay, so walking through this. I'm going to come in and I'm going to run it. First things first, I can just start monitoring. I can list my banned IPs and their status. I can list my whitelisted IPs, or I can just unban everything and allow everybody to be free, if you will. So that's me essentially removing all the things I put in place. I'm going to go ahead and do start monitoring. It's going to say, hey, I'm going to whitelist all IPs associated with this machine. Are there any other ones? Nope. I just want the ones associated with these machines, and cool. That's my list of IPs for this machine. It's now going to start listening, and I'll come over here to another machine, and I will try to log on. I got the threshold set here for 3 within, I think, like 30 seconds or 25 seconds. So now that I've triggered that, on the next go around, when it checks for its status, if you will, it should trigger. All right, so it triggered, it added a firewall rule to get after it. I'll refresh here and I see that ban. It also committed it to the event logs, and my system time is 1440. 1440, I see that this block, I see that this was put in play, and that block expiration is going to happen at 1440 08. If I go here, I see when that event generated. So I have all this now committed to my event log, and I'm going to ship it off. Here in a second, that time is going to expire, and it's going to release it, right? We see it's now been released. I'll come back in here, refresh my firewall. I see it's gone. But again, I've already committed that entry to my event logs, and now I can parse this out. I got my blocked IP. I got when it was going to be expired. I also see the rule it went under. I see when that time generated. Now, this guy becomes to be a problem for me long term. I'm not going to do it for 30 seconds. I'm going to do it for months. And I can start to configure that. Hey, this is your first offense, 5 minutes. Second offense, 3 days. Third offense, you're done, right? They're going to give you life, if you will. Cool. So that's invoke fail to ban. All right. So from a red team perspective, we could also use PowerShell for a number of things. One of the things I like to use it for is data storage, right? So I can take my data, my binary, if you will, convert it to bytes, convert it to base 64, and then store it. Or I can do some variation of that with hex and a number of other formats. At the end of the day, it doesn't necessarily matter what format I have it in, other than it being some form of text that I could input. Now, where could I store this data? Well, places like the registry, man, that's a gold mine. Active Directory, event logs, alternate data streams, group policy objects, anywhere that I can actually input data is where I would put it. Why would I do this? Well, it's there when I need it, and it's less likely to be found, right? Because I'm doing it from a file list perspective. From the aspect of Active Directory, right, this is where we're going to do our authentication and authorization within a domain. Most commonly uses users, computers, and objects. The groups, rather, they're all objects-oriented and arrayed in organizational units. Cool. So if I looked at a user, in this case, Nick Shank, I see all the properties associated with him. From the right, I'm utilizing the GUI. From the black screen on the left, I'm utilizing a little PowerShell there. Now, I see a number of properties that aren't utilized. I probably wouldn't utilize the ones that are right there in my face that a sysadmin would commonly use or even know about. Roughly speaking, there's probably over 50 or so properties that are available. Some of them have limitations in amount of data that we can put in there. What's good about this is domain users can read this by default. Something like the division property is one of my favorites. The division property allows me to store somewhere between, I think, 512 and 1024 characters. For me to see it, I need to go in attribute editor from the GUI perspective. From the command line perspective, I'd have to purposely go look for it. Most people don't even know it exists. And I'll take my chances of an admin going into attribute editor and seeing my code off to the right there. Now, if I'm worried about him seeing it, what I'll do is pad those characters so that way my code starts or is visible off the screen, meaning they would have to scroll over to even know it. Most admins aren't going to do that. They're just going to be scrolling up and down looking for whatever they came there for and not necessarily scroll to the right. But in this case, I got some base 64 code that I got sitting there. Now, we could also do this with the registry. I'll just take whatever key value, make my own, utilize something that's not really known, and just go deep in there. From the perspective of this, I put it right under HKLM in software, horrible place, all right? But I'm gonna call my value updater 32, and then I'm gonna specify some code. Again, just like with Active Directory, if I'm worried about somebody seeing it, then I will push that code off the screen. In this case, I just padded it with 160 blank spaces, if you will, no characters. So now looking at it, an admin wouldn't know, but if he double clicked that entry, he would then see my code. Again, I'm hiding in plain sight, essentially amongst every other key that's there. When I need this, I can go read that key, read that value, convert it back to its raw character, and then execute it. But for as long as I need it, it can just sit there. Awesome, right? Fileless malware. All right, so we can do port scanning as well. I don't necessarily need Nessus or ACAS or Netcat to be able to do port scanning. I can do it right off a Windows machine with PowerShell, right? So from a version 2 perspective, we're going to use NetSockets client. From a version 5 and newer of PowerShell, we can use GetNet connections, right? We could also do banner grabs. So after I understand what ports are open, I could massage those ports, see if we can get anything back from it. Maybe identify an operating system service version, anything that kind of helps me understand that machine and what I'm working with. Definitely typically used by the red team for a fingerprint perspective. Blue team, though, could utilize it to identify misconfigured machines. Hey, why is this port up on this machine? I don't know. Well, let's see if we can banner it. Oh, we did get a banner back. What is this, right? Kind of preliminary before we dive a little bit deeper into it, but primarily used from a red team perspective. Okay, so let's demo this. So on this machine, I have a number of things running. From this machine, we'll go ahead and do a scan. So I'm going to invoke my port scan, roughly 20, 25 lines of code. I'm going to specify a system, and I'm going to feed it a list of ports. I'm going to let it go. And if I needed to do more than one, just like I did more than one port, I could actually do more than one systems at the same time. Hence why under remote address, I get the IP back, because if I have more than one, I need to be able to differentiate them. I see the remote port that I tested, and I see the status. So based upon this, I get 4 of the 5 ports back. I might have an hypothesis as to what type of machine this is, but now I'm going to look at trying to do a banner, same IP, same list of ports, and I'm hoping that based upon what I get back, I can be led a little bit closer to what I think this machine is. Okay, so I didn't get a banner back for everything, but I got 2 banners back. For SSH, I got that it's a Bitvise SSH server. When SSHD, that almost starts to tell me it's Windows. So I'd go out to my friendly Googles and I'd probably Google that to see if if this binary runs on a Windows machine. Is it indicative of something that's cross-platform or what? If that wasn't enough, I see that on 80, I got Microsoft IIS 10.0. That definitely, in my opinion, helps point that this is a Microsoft machine. And I'm utilizing nothing but PowerShell, right? There's no other things that I'm bringing in. Quick, agile, and already there. All right, so simple HTTP Posh server. So if you're doing red teaming and you're using Kali or whatever your flavor is, and you have that Python simple HTTP server, well, here's a variant of it from PowerShell, right? So we can stand up a web server very quickly to serve up content. Maybe we need to reach back and grab it. If we want to do an HTTPS one, we could as well. This is something like 40 lines of code. With HTTPS, we're going to add in maybe another 10 to 15 and be able to do that. We can customize the listening port that we want. If it's anything that's a well-known port, it's going to require admin rights. Anything above that, we're good to go with a regular user. We can stand this thing up, get what we need, terminate it, be good to go. And then by default, it's going to serve content on the desktop. We can specify where we want that stuff to be hosted from. But we're going to use this post-exploitation, right? I'm already out somewhere, and I'm going to use this as a reach back to grab something additional, right? Or maybe I'll stand this up when I know my fileless malware is configured to run, and maybe it's reaching to my simple HTTP server built in PowerShell to retrieve other things. And once it contacts it, I'm going to stand it down. Maybe I'm doing some type of cookie as far as authentication, or a combination of a number of other things. All right, so let's look at this. We'll come in here, and I told you a story, 86 lines. All right, so I'm looking, or I'm going to house this on port 9000. This is going to get created as a job, so now it's in the background. I get my terminal back if I need it. I'll come over to my other machine, and we'll come over and we'll navigate to that server that we have stood up. And everything on the desktop is now being served to me. So let's say I came here and I just needed to grab Netcat real quick. I can click on it. Netcat's going to be downloaded to my local machine and all is well. When I'm done with it, I can just come back, terminate it, and then that machine, that server is now going to be offline. So we see that I'm no longer able to access it. It's just going to spin. It's finally going to time out on me, right? So I stood it up, tore it down very quickly. All right, so that brings us to the end here. PowerShell is a powerful language, right? Goes way beyond typical sysadmin. And even though it's been abused in the past, the developers have made astronomical leaps to make visibility at the core, but it still continues to get abused, right? And this is where living off the land comes in. So we can do things like malware stagers, implant handlers, memory injection port scanning, as you've seen, right? And then from a blue team perspective, I can utilize it to interrogate a machine and do a subset of tasks that I would do if I was sitting in a SOC or even doing forensics and malware analysis. All right, so if that wasn't enough for you, and maybe you're sold, I got some other stuff for you, all right? Maybe you want to learn PowerShell and you're just not there yet. If you've heard of Under the Wire, thank you if you played it. If not, Under the Wire is something me and two other people came up with in 2015. We give you a subset of challenges, and every challenge, the answer from that challenge becomes the password for another user. That other user becomes a different level in the game. The tasks sometimes are easy, sometimes are difficult. If you have to research something, nothing wrong with that, because guess what? You're learning. Right now, there's 75 challenges in there, and they're linear in nature, meaning you're going to have to do one after the other. They focus on core aspects of PowerShell. To date, we've had about 140,000 unique players from over 84 countries. Underthewire.tech. All right, also there's Posh Hunter. Posh Hunter is something I did on my own back in 2017, and this is non-linear, right? So I'm going to give you a virtual machine riddled with artifacts, and then I'm going to give you roughly 90 or so questions, and each one of those questions puts you in the mindset of either a pen tester or a digital forensics and incident response slash SOC analyst. So they're scenario based, and you're going to utilize PowerShell to be able to go in there and answer those questions. I take away a lot of the GUI aspects of the virtual machine, trying to force you to utilize the language. Again, this is going to be red and blue team focused. From the under the wire perspective, what I failed to mention was you're going to access the game via SSH. So already we're going to put you in such an environment that forces you to utilize the language. What comes out of both of these platforms and you using them is truly growth. The more we're exposed to different things, the better we become. All right, with that, if you have questions, I'm not sure if we're taking questions now. If not, I'll be available outside of this. This presentation, you can find it on my website. And then also all the code we talked about here, it would do me no good to talk about the code and not make it available. So you can find that code on my GitHub along with other projects that I'm working. And if you want to interact with me beyond this presentation, please reach out to me on Twitter. Again, thank you, Rocket Secure, for having me. I really appreciate it. I really appreciate everything you guys are doing. And again, as an Alabama native, please keep up with what you're doing. And look to interact with all you guys one day in the future. All right. With that, Neil, I'm done. Yes.
So I'm back on here. I'm going to start up my meditation music again for the next 5 to 10 minutes. Sorry if that bothers anybody or puts them to sleep, but SSA Pierre will be on in just a minute. I'm going to get him connected and then we'll be right back. If you have any questions at all, you can post them in the chat. Um, as well as if there's been a lot of questions about CPEs. If you're trying to get CPEs, you can still register for Rocket Secure right now. That'll get your email in the system, as well as you'll when you hit the chat, we know you're here and talking, and that'll be one of the ways that we'll do CPEs for this. If you have any other questions regarding CPEs or registering or sharing the link or whatever, this is totally public available right now. So go ahead and post it in the chat. Okay, there was a few comments about the volume. Can you guys hear me okay now? And I'm just going to look to the chat to get your feedback. As far as what I'm saying, not as important what the speaker's saying. Can you hear me now? A lot better? Okay. 50% improvement. Jeez, I'm still sitting at like failing like a low C. All right, I'll hang up on this one and try that out and see if I get it there. Sounds good. Okay, I'm not going to worry so much about my volume in this. I think it's just because I'm going through just the laptop microphone, but but the actual speakers feeds are coming in fine. So I'm going to do most of my communication via the chat window. So if it's not something coming in from the speaker, which I can verify the volume is okay, I'm not going to spend too much time worrying about that. You guys did not come here to listen to my voice anyway. But I'm going to post some information into the chat regarding the CPEs as well, so that people know how they can register and still get their CPEs for attendance today. And I'm going to go mute again here. You're not going to hear anything but this awful meditation music. And we'll be starting up in like 5 minutes. So I have killed the meditation music. I apologize to anybody who was enjoying that. The next speaker is Supervisory Special Agent from the FBI, Supervisor Pierre. He will be talking to you about some cyber type related activities, and then maybe some more stories. And I'm going to turn it over to him. And let me just transition here real quick.
Can you hear me, Neil?
I can, and they can as well.
Sure. So good morning, guys. Sorry my video is not working, and couldn't get the Skype client installed quick enough on the device that I'm using, so we'll have to just do it via voice. But usually I keep this pretty low key, so if you have any questions as I go along, I will answer them to the best of my abilities. You can go ahead and just interrupt and ask it. And I think Neil said there's even going to be somebody's attending to the chat window or things like that. So yeah, if somebody pops a question in there, just let me know that it's there, and we can try to answer that as we go along. So just like Neil said, Scott Pierre, Supervisor Special Agent of the Cyber Squad for the FBI Birmingham Division. We're going to do a cyber threat briefing today. So I'm going to give you a rough idea of the things that We work on in the FBI as a cyber squad. So what our priorities are, how we're structured, what some of the big criminal things that we're seeing, touch on a little bit of the national security stuff, obviously things that are unclassified. And so to even kind of just set the ground rules there for the questions as well. You can ask any question you want. I'll do my best to answer them, but if it starts venturing over into something that's classified or something of that nature, then I'll just tell you that that's something that I really can't talk about or answer, and we will move on to the next question. So with that, the way the cyber priorities of the FBI are laid out are basically from congressional funding, right? Counterterrorism is going to be the number one priority of the FBI, of every squad that works in the Bureau for the foreseeable future. It's been like that since 9/11. And that's what the majority of the funding goes to, and it's what everybody is tasked to make the number one priority. So we do have a few terrorism-related cyber investigations. We don't have any here in the Birmingham division, but across the FBI, there are a handful of them. What does wind up happening, though, from time to time, is that so an instance would be the shootings at the recruiting centers up in Chattanooga a few years ago, or the arrests that people may have seen on the news or things like that of some terrorism subjects downtown Huntsville about 2 years ago. Those type of activities do occur. Those are worked off of our counterterrorism squad, but because of the fact that FBI Birmingham is one of the smallest divisions, so we're in the bottom 5 of the 56 field offices in the FBI, size-wise, so we have 5 fewest number of agents out of all 56 divisions. Because we're a small office, when something terrorism related pops up and it requires 24-hour surveillance or whatever the case may be, most agents in the Bureau, doesn't matter what your career path is. So even though I'm a cyber tracked agent, and then all of the agents that work for me or my squad are as well, if something happens CT related and the resources requirement are there, then we're going to all be CT agents for that week or that month or that 6 months, whatever the case is. And we would literally set aside the cyber cases that we're working, and we would go work CT because it's the number one priority of the Bureau. So with that sort of established, CT is number one priority. So cyber CT is the number one priority in cyber as well. There's not very much of it. The cyber national security investigations are the bread and butter of what we do. I would guess that that's 75 or 80% of the cases that the agents on my squad work, and what their workload is. We sit in Huntsville. The majority of our squad does. I've got 2 agents that sit down in Birmingham, and then the other 5 sit up here with me in Huntsville. We have the second largest defense contracting base in the country. So per capita, second in the country, only to Washington, D.C. And obviously with that large of a scale of defense contracting going on here in this area, there's a ton of intrusion activity that goes along with it. So you have a bunch of nation state actors from various different places in the world trying to steal, gain access to whatever the case may be, these defense contracting networks. So that keeps us pretty busy. I would guess 75 to 80% of what we work on is cyber national security investigations. The other 25-ish% would be cyber criminal investigations. And so the agents on my squad, we don't have really agents that are strictly national security cyber folks or strictly criminal cyber folks. They work both. And we do that for a couple different reasons. It keeps them from getting burnt out on one or the other. Plus, it helps them to keep a wide range of skill set going for future promotion opportunities. It just makes them better, more well-rounded agents. We have, I've already sort of mentioned it, but I'll cover it in detail here. We have 7 agents. And so you think about that. That is not a lot of agents to cover basically from Tuscaloosa all the way to the northern border that we share with Tennessee. So those 7 agents are responsible for all the cyber investigations in the state of Alabama from Tuscaloosa north. From Tuscaloosa south, that's what FBI Mobile Division would cover, and they have an even smaller cyber squad than we do. I think they only have 3 cyber agents in the entire field office. So really, really small cyber squad. So you've got 10 agents in Alabama covering all the federal cyber crimes that the Bureau does. That is not a lot, comparatively speaking, across the FBI. And then obviously just in a common sense kind of a thought process, if you guys think about that, for 10 folks working all the federal crime in Alabama, in the scale of what we see, there's not very many. And so that does require us to have to be judicious about what we spend our time working on and the type of cases that we take. Unfortunately, on the crim side, that means the dollar loss value in some of these business email compromises, ransomware cases, any of those type of frauds that go on that are facilitated by computer intrusion, the dollar loss value's got to get up there. When I say up there, we're talking 50, 75,000 loss at a shot at a minimum. And the overwhelming majority of the time, we're talking in the hundreds of thousands or millions at a shot in loss before we can open a case and start working on it. And we have more cases than we can work. So unfortunately, that is an indicator that that type of dollar loss happens on a regular basis because we are not lacking for cyber criminal cases to work on. What does the cyber threatscape sort of look like out there? It's wide ranging. It starts sort of at the lower level. So we would talk about the hacktivist level so you start at the lower end of the scale would be our hacktivist, and you would have your lower tier cyber criminal actors, insider threat people, so people that could facilitate nation state intrusion attacks or even sometimes criminal intrusions by being an insider who has access to systems that are difficult to get to. So maybe it's an air gap network or something like that. And so they have physical access to the building or to the box, and they can pop a thumb drive in it or do something to that effect that would give someone access to it that normally could not get it. Espionage, terrorism, and then warfare would be at the very, very highest level scale. So you would think when I say hacktivist that's kind of low threat, and it is, but the problem with the environment that's out there today is that there are just kits out there, there's things available for sale, let's say. I don't want to mention specific ones, but the cyber underground now has become pretty professionalized. So it's pretty easy for a 13-year-old or a 14-year-old to go out there and get a toolkit that would allow them to scan an IP address and have that toolkit tell them, hey, this IP address is a Windows 2000 server. It's running IIS. It has these 6 vulnerabilities because it's not patched here, 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 and here. And so here are the vulnerabilities that you can deploy against it. Choose 1, 2, 3, 4, 5, or 6 for which one, and then it would obviously list out what each one of those vulnerabilities would do. And you would choose number 3 or whatever the case may be, and it would give you access via command line to that box. It literally is that easy to hack systems now, and obviously me saying that to you guys on this open call, I will tell you that if you go out and do that to someone's system, that is against the law. So do not go do that unless you have permission to do it, because that could prompt a visit from us or from your local police authorities if you do it and you're caught. So definitely don't go out there and try to test that. But that capability is out there. And because that capability is out there, it makes it really, really easy for people to gain access to systems. So when I say hacktivists are at the lower end of the sophistication level in the cyber threatscape, that doesn't mean that what they're doing is not successful. It is successful. Several years back, I worked a case where multiple agents across the Bureau did, where Anonymous was really, really active, and they were basically recruiting people on social media and various internet forums to download this tool. They called it the Low Orbit Ion Cannon. It really wasn't anything sophisticated at all. And so all it really did was a denial of service attack against 3 or 4 of the main banks in the United States of America. But because of the power of social media and the scale of it in some of these forums, people joined. They wanted to be part of this group. They felt like their voices weren't being heard. They were convinced to download this tool to their computers. So just a tool that was downloaded to their home laptop or PC. And then several weeks later, we're told, hey, today's the day. I want you to pop in this IP address and hit start. And they popped in the IP address and they hit start. And what you had was, thousands or tens of thousands of computers all hitting the web servers, because that's what those IP addresses resolve to, of 2 or 3 of the biggest banks in the country. And it literally took those web servers offline for several hours. So not sophisticated at all, really, really easy to pull off, but very, very effective. Literally taking down online banking services for several of the largest banks for multiple hours at a time through a quote unquote hacktivist group. The warfare, so the other end of the spectrum, is the one that we worry about the most. And obviously we look at that. The Department of Defense looks at that. Pretty much everybody in the U.S. government looks at that. And that is where you could weaponize some of this capability through intrusion activity. And the biggest fear and the biggest thing that's looked at right now is through ICS, so industrial control systems, and SCADA systems. Those are systems that control nuclear power generation. They control large gas lines, wind turbines, air traffic. A lot of our financial system is run across that. It's basically the critical infrastructure of the United States of America runs across those type of systems. And so the issue there is that a lot of the things we see and work on a daily basis are involving either hacking to exfiltrate data on the national security side, and that's pretty noisy, or hacking to facilitate cyber crime, which is the loss of money, and that is obviously the most noisy because at some point the victim is going to figure out that 50 grand or $5 million or whatever it is missing out of their bank account, and they will know that, and they're going to know that pretty quickly. So those are noisy as well. When you get to the warfare side and the ICS SCADA side, there's no data to exfil. All they do, or all people would need to do, is to have access to a device and to make sure that they maintain persistent access for 6 months, a year, 10 years, whatever the case may be. And the only time that that access is ever going to be exploited is if the United States goes to war with that country. And at that moment and in that day and time, those actors would then utilize that access to, shut off traffic lights, blow up nuclear power stations, whatever the wildest scenarios you could kind of come up with. No one really knows because it's never happened before. And it's not just theory because we know that these vulnerabilities and accesses exist. No one's just seen it actually deployed yet on a very large scale. There's been one-offs, and DHS has done testing to show that some of these gas systems can be overpressured and cause explosions and things like that. But it has not actually happened on a very large scale yet, but that is obviously the worst case scenario of what these cyber-enabled attacks could be used for. And so hopefully that never happens, but we are definitely looking at that and trying to figure out ways that that could be used against us, and then ways obviously to protect against it. So let's talk a little bit about how this threat has evolved. I've been in the Bureau 12 years and some change now. Have worked cyber for the majority of it, 7 or 8 of those years. I've worked violent crime a little bit as well, but I came in as a new agent and worked cyber crime to begin with. And so the threat initially was really, really unorganized and disjointed, but it has become more and more professionalized. If you stole, let's say, 1 million credit card numbers 15 years ago, because you had access to some point of sale terminal or some database on the back end, whatever the case is, and you got access to this numbers, that are not really useful unless you can find the specific buyer for them, how would you sell that or what would you do that? If you had that 15 years ago, it'd be really difficult to liquidate that and actually get money for it. Well, now, because of the quote unquote dark web and these marketplaces that are out there and the fact that this underground has gotten very professionalized, there is a market for data like that, and it's very, very lucrative. So it makes it much easier now, and because it's much easier, it's also more attractive to a wide variety of people to get into that quote unquote line of work, because now you don't have to search the globe to find an end user for your material. You post it out there on one of these forums, and people will offer you money or want to send you Bitcoin or whatever the case may be to buy these data sets from you. And so because of that, it is facilitating a large spike and an exponential rise in that type of crime. What it also does is it creates a marketplace for exploits, like we talked about, but also access to systems, data. Like I mentioned before, you can literally go on these forums and get an exploit if you want it. You can get a very low sophistication level rootkit that's going to do some things for you. You can say, hey, I don't want to bother with that at all. I have enough money. I want to pay someone to actually go hack whatever for me. That service is out there as well. And then there's also people out there that are just selling access to certain companies or networks. And so that's the next level up would be, hey, this person's already hacked them. They already have access. I need access to that network, so I'm going to pay this person for their access. All of those type of services are out there. Unfortunately, drugs are out there available for sale. Pretty much anything that you could think of that's humanly possible to be sold is out there on some of these dark web forums being sold. Some of the things we see, like missile systems and whatnot, helicopters. I wonder personally, if you bought that through Bitcoin, how are they going to deliver a surface-to-air missile to your door? I don't know how someone would actually pull that off, but you do see things like that out there available for sale. And so I wonder from time to time if that is actually something that could even be delivered. We also see a rise in the level of sophistication of the organizations that are running these type of criminal computer intrusions. And so because there's so much money in it now, you're talking hundreds of millions, if not trillions of dollars, billions and trillions of dollars that are being stolen over the course of last 5-10 years. These are very, very well-oiled machines now. Large-scale criminal organizations, they have people that work for them that are employees. And so you have people that do the coding. You have people that handle the processing of various different bank systems, which are very complicated, and people run them. So payroll processing, bill pay systems. There's a wide variety that are, the network is compromised. They get the credentials to these type of systems, and then the next thing you know, ACH transfers, wire transfers, whatever the case may be, are being sent to accounts controlled by these criminals. Those are not easy systems to know how to operate. And they have people literally on standby the second that that account is compromised, ready to go. And they know inside and out how to work these systems. That's not something that they just are doing. They're not flying by the seat of their pants. They have practiced and trained and done those things. And so they have a scaled organization in place to be able to facilitate this type of crime. There are people out there recruiting money mules. There are people doing the processing. There are people doing the coders. You name it. It's a really, really well-oiled, large-scale organization. And so that's what we try to target. And a good way to think about this is the numbers sort of vary from year to year, but on average, a bank robber, so if somebody goes into their local bank and they pull out a gun, which would be risking their life, that they could be shot doing that. A lot of bad things could happen to them. They pull out a gun and they rob a bank. They typically get somewhere between $5,000 and $10,000 at a shot. And that's something they're risking their life on. Where the people I'm talking about are sitting behind a computer screen in their living room in a country that does not have extradition treaties with the United States of America, so they cannot be extradited. If we do identify them and get arrest warrants for them, their country will not go arrest them and send them to us. And they're stealing 50,000 and 100,000 and $1 million at a pop. And so you can see pretty quickly that the scale, the risk is very, very low and the reward is very, very high. And you also have areas of the world where, for whatever reasons, governments have broken up, and these were historically places in the world where the population was well educated. There were pretty good economies there. So you have people that have technical skill sets that were employed in legitimate industries, and their economies have sort of broken up or fallen apart or whatever the case may be. And so you have these people sitting out there that have very, very good technical skill sets, but there's no marketplace or economy for them to have legitimate jobs in. And so it makes it easy for these criminal organizations to recruit those people with the necessary skills to effectively perpetrate these types of crimes. And so that is part also of what is fueling this large scale rise that we've seen in the last decade or so. So now let's go through the anatomy of one of these attacks. And so how does an attack typically happen? The first thing that's going to happen is recon. And recon nowadays is super, super easy because all of us have too much information out there about ourselves in our personal lives and our professional lives on the internet. And that cat's out of the bag, and there's not really a lot that we can do to change that, but it's just more of an awareness piece now of knowing I could get a very well-crafted spear-phished email that's believable and probably would convince me to click the link, and it's because there's so much information out there about me that someone does a little bit of research. And again, just like I talked about before, if they're working in one of these organizations, it's literally their full-time job. They go to work every single day to do that, just like we all go to work in whatever various industry we work in and do our job. They are looking for ways to get you to click a link, and that's all they do every day. And because they have nothing but time on their hands, and these are such large payouts on the end, they can spend hours and days and weeks trying to figure out everything about you on social media, LinkedIn, your company's corporate webpage, whatever the case is, to get where you went to high school, where you went to college, your wife's name, your husband's name, your 3 kids' name, your dog's name, what kind of sports you enjoy, what your hobbies are, who your favorite team is. All of that stuff is out there. And that makes it really, really easy to craft very good spear-phished emails. We've seen them to the level of sophistication that someone in a company got an email from the CEO, and it was someone that was a couple levels down, and the CEO never really emails them. But the CEO's wife and this person's wife were talking on Facebook, and open. One of their pages was open to the public, and so people that were targeting him could see they were basically thanking, hey, thanks for having us over for dinner. Talked about whatever was served. It was really, really good. Tell Bob that Bill can't wait to see him on Monday, blah, 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 right? Well, the threat actors saw that, used that in the spear-phished email to say, hey, thanks for having us over for dinner. It was a great time. We really enjoyed the lobster or whatever it was. And, oh, by the way, we're leaving to go out of town tomorrow, and this bill is 45 days overdue. I need you to have our processing system or our processing center run a $500,000 payment to this account. I don't want it to be late. And so the person obviously doesn't interact with the CEO all that often, had just had dinner with them, knew that that was something that happened. They believed it to be legitimate, and they wire the money. Of course, it doesn't go to whoever the vendor was that needed the real payment. It went to someone overseas in a country that's not going to extradite, so that money's gone. Those type of things happen on a regular basis, and you just have to be aware that the awareness piece is the key. Be aware that there are literally people out there every single day whose job it is to try to get you to click the link or to get access to your network or to get access to that type of information so that then they can exploit it because there's such a big dollar payoff at the end. Recon is the first phase. Once they send that spearphished email and get you to click the link, the second phase of the attack is the initial compromise. And so once they get you to click the link, now your box is compromised. They're going to try to establish a foothold in the network wherever they can. Once they do that, then you will see additional recon now from inside the network. And so they're trying to find, payroll processing, payment systems, whatever it is that a company would use, and that's kind of industry dependent. They want to know where that is if they're looking on the CRIM side. If they're looking on the national security side, they're going to want to know where your CAD server is or your file server or basically any of the places that hold the repositories of data that are the crown jewels of what you work on, so your intellectual property. And they're going to find that, and then they're also going to be looking for ways to exfil that data off of your network. And so where are all of your entry and exit nodes to the internet? What is the least secure one? What protocols are open or not blocked? And what is one that's not commonly used, that's not being scanned or looked for, that I can use to just very small increments exfiltrate data off of your network? That is going to happen. And on the national security side, their goal is hopefully to continue to do that for years and years and years and have you never realize that you have a compromise. And that really is, so I keep kind of coming back to that awareness piece. I would say the overwhelming majority of our interactions, even on that side of the house, on the national security side of the house, it's convincing people that this is actually not, something that you read about in a James Bond novel that's possible but will never happen to me, but convincing them that the devil's real and he's out there looking for you every day because there are teams of people out there. This is their job, and they are going to try to get your network. And if you have a great system in place today, that doesn't mean that tomorrow they're not going to get you, because the last thing in the world that's going to happen in any of these instances is if a bad guy wants access to your system and they can't get it today, they're not going to say, oh, you know what, you got me, your system's too good, I'm just going to quit and give up and go get a new job. That's not happening. Tomorrow they're going to come back and they're going to try to figure out another way, or to try to find a different person that'll click the link. And if that's not successful, the next day they're going to try something else and something else and something else until they are successful. That's what the threat is. It's not this, and that's what's hard to get people to understand and wrap their minds around until we're sitting across from them with their data, or they have called us and said, hey, we just lost $2 million out of one of our corporate checking accounts. Please come help us. That's when they know it's real. And then we start looking and can show them after the fact, here's exactly what happened step by step by step. So once that foothold is established, they will escalate privileges on an account and move laterally across your network, and then obviously begin exfiltrating your data. The end goal is sort of what I just said. They want to maintain persistence if they can. Hopefully, if you find out you have a problem and that you've been compromised, you are able to remediate that issue, get it out of your network, and then establish some security protocols that will prevent it from happening in the future. That's the end goal. Doesn't always work out like that. Most of the time it doesn't work out like that. One other thing that I really kind of want to make sure I hit home here is I would love to tell you guys that I'm sure you've seen it in the movies that are out there and the TV shows that are out there, that you think it's the 0 day or the big sexy cyber topic du jour, that's how someone gained access and that's why we're there. I've never seen a 0 day used in any investigation that we've ever had. Nearly every time, the way someone gets access to the system is someone clicked the link, or it was through a system that was not up to date on its antivirus or its patches. The reason those things come out are because nearly every time, not every time, sometimes it is for performance enhancements, but the majority of the time it's to fix a security vulnerability. And if any of you on the call are a lot like me or the people that I know or the ones that work for me, it is a pain when that box pops up and it says, do you want to install whatever the update is right now? It gives you the choice of now, later, and we all look for the button at the bottom that says update never, but unfortunately that one's not there because none of us like rebooting our computer and stopping what we're doing and letting that thing run for 30 minutes. But the reason it is running is because it's fixing a vulnerability. And when you get these very, very large networks, you can see pretty quickly that some people, they do the update right when they get the reminder. Some people do it tomorrow. Some people do it 2 weeks from now, and some people literally never do it. And so there's various states of security all across the network. That's what we see nearly every time. That is the vector. That's what allows the 13-year-old that gets the kit to be able to scan an IP to see that here are the 5 vulnerabilities because this machine is not patched. That's what's happening. It's not someone is developing this never before seen piece of malware that is a 0-day that they're deploying against your network and getting access. I've never seen it happen. It's always that. And the other thing is, and I'm going to cover that here in a second when I start talking about our biggest threats, the other thing that's not happening on a regular basis is, so with ransomware, the biggest fix to ransomware is to have backups. And time after time after time after time, when we go out on these type of cases, either they have backups and have never actually tested restoring from backups, so they don't know if it's going to work or not. They don't even know a lot of times if the systems that are mission critical are backed up. There are backups out there, but they don't know what data is on the backups. So you run into that. And then a lot of times there just aren't even backups at all. The actors are getting more sophisticated now, so they're even trying to defeat it if you do have backups. But I would love to tell you that that's the case every time we go out, that the backup system is there, everything that needs to be backed up is, and they have practiced before, and so tomorrow they're going to restore and we're going to be good to go. That is, less than 2% of the ones I'd see. Almost every time, something with the backups is not good, and so then you're stuck being held hostage by someone that has encrypted everything on your network of if you're going to pay, or do you just start from scratch tomorrow and rebuild your entire network and rebuild all that data? Huge problem, right? And again, that's one of those basic things. It's not really the really super sophisticated things that we see all the time. It's literally the basics, the blocking and the tackling, not quite being done like it should be, and that makes your company or your personal systems vulnerable. So what are some of the biggest threats that we're seeing currently? Business email compromises are one of them. Hang on 1 second, guys. We got a question. So that looks like several questions. So yes, anytime you have what you believe to be a computer intrusion, you can contact the FBI. So you basically want to just look up your local field office and give them a call. There's going to be somebody there that's doing complaints that day. So they probably will not be a cyber agent. That's just the luck of the draw. All the agents take turns doing a rotation. So they're all on a schedule. But what they all do is take the call, figure out which squad that violation would pertain to, and then they route a guardian, which is the system we use, to the proper squad, and then that supervisor would assign that guardian to an agent, and the agent would start working on it. Yes, we are seeing a big spike in the Ryuk ransomware stuff across the country. So some of that here in our AOR, but also across the country. And are we hiring? Yes, but that's a tough question to answer because I don't know exactly what area you would be looking for, Neil. So we are hiring, but we have various different, so I'll give you just a rundown of what we have on our squad, and that can kind of give you a flavor on at least the cyber side. So obviously we have FBI agents. We're hiring for that for sure. We're hiring all of the positions, but it's just a cyclical type thing. And so you just go to fbijobs.gov and search. And I think actually if you go to fbijobs.gov/Huntsville, that will show you all of the Huntsville jobs that are available related to the very large expansion that's happening up here. So you have FBI agents on the squad. You have intelligence analysts on the squad. You have staff operations specialists on our squad, which are basically, they are intel bodies as well. And so the intel analysts are more of our product writers. The staff operations specialists are more of the people who are in the weeds on the cases, trying to connect the dots and do deep dives on data sets and things like that for us. So we have that. We have a computer scientist, so a really, really technical guy who's a coder. He helps us. The big thing he helps do case-wise is on cyber, we are always dealing with really, really large data sets. And those data sets obviously need formatting, and sometimes they need, we have, millions or billions of records or whatever it is, terabytes of data, let's call it, and we need to look for very, very specific things in it. And so he helps the agents format that data, and he writes scripts that helps parse through and find exactly what they're looking for, because if not, they would spend the next 3 years searching through the data, looking for one small piece of evidence. So you got a computer scientist. We have a data operations specialist, which is sort of like a computer scientist light. That person on our squad wears a variety of hats, and so he's kind of a cryptocurrency type of a guy. He does some of that data modification for us as well, kind of a jack of all trades. So that's out there. We have operational support technicians as well. So that's kind of they used to be like our squad secretaries. They handle a lot of the admin role for us, and then they also have a little bit of an analytic capability as well. We have a forensic auditor on our squad, so that's a person that is a licensed accountant who's gotten into the FBI, and they do a lot of the. Obviously, you've heard me talk quite a bit already about the amount of money that's being stolen, and so obviously that's kind of a bread and butter investigative technique for every law enforcement agency out there, is to follow the money, because it always works. It's been effective since, I'm assuming, law enforcement investigations began, and it will be effective until the end of time. And so we have people that we hire that are accounting experts to help us, quote unquote, follow the money. So that's what our squad makeup sort of looks like. And the Bureau, depending on if you're willing to move or if you're really locked down to a geographic area, I would say that we are hiring in all of those positions right now somewhere across the FBI. Does that answer the question, Neil? Thank you. Any other questions? Okay. Well, what's that, Neil? Cool. Okay. Thank you, sir. So I'll throw out there, we're talking business email compromises. The business email compromise is basically where, again, it can be somewhat sophisticated. A lot of the ones we see now are not sophisticated at all. So when I say it's somewhat sophisticated, those business email compromises are someone actually hacking into an email server in some form or fashion, reading email traffic, and then using that knowledge and the access to that server to then craft a very, very specific email to someone to get them to send funds, believing it is paying a bill, running a payroll transaction, any of those type of things, to a place that it should not go, typically overseas and in a place where we can't get the money back from. So if some of those that I've seen in the past, there was one that was really, really popular, I don't know, 5, 6, 7 years ago, where it was Zeus malware, and that thing would literally, if you click the link, it was targeting specific payroll processing systems and banks, and it literally had the list of banks hard coded into the browser, that when your browser hit the bank website, it had this list that was, I don't know, 100, 150 banks long, and it didn't do anything until it saw the browser hit that bank URL. And when it hit that bank URL, it started recording. So it was screenshotting your computer, and when you hit the URL and went to the login page, it would redirect you over and over and over again. And we've all done this multiple times where, because you have so many different passwords out there, and it gets more and more difficult every time that the requirements do, it's hard to remember them. And what we all do inevitably is we fat finger our passwords on a regular basis. And so it's not suspicious if you go to your banking website and you enter in your username and you pop in the password and it pops back up and you think, oh, well, I just fat finger my password, let me do it again. But it just does it over and over and over again, loops it. But what's happening is, and also, so they were not only doing it with usernames and passwords, started with usernames and passwords, it actually evolved into using RSA IDs as well, the tokens. And that token, I guess, lasts for somewhere around 1.5 minutes. I think they say it's a minute, but there's a little bit of a residual that it's active even a little longer. And so this will tell you even more about the type of support networks that these criminal organizations have as well. They didn't know that I'm about to log into this bank account. But the second I did, somebody over there is waiting on the other end, and they have the skill set that it's recording my screen now, and it's grabbing my username, my password, and my RSA token. And then when I hit enter, it redirects me, and I think I entered something wrong. I didn't. They are now using those credentials to log into our corporate checking account, and they're in there, and then they're creating wire transfers or ACH payroll transactions to accounts that they already control or to money mules that they have already recruited and hired, and within 10 minutes, 15 minutes, 20 minutes are sending out hundreds of thousands of dollars, all while I'm thinking something's wrong with my account. And eventually I'll get to the point where I'll call the bank and I'll say, hey, something's going on. Is my password messed up or whatever? And they will call and say, no, you just initiated, 14 wire transfers. And the person obviously would say, no, they didn't. And that would prompt a call to us. That is one of those type of criminal, sophisticated hacks that we would see pretty regularly. But that involved someone clicking a link to give them access to the system, right? And that was either through a spearphished email or an unsupported or unpatched system. We see a lot now where super low sophistication on a business email compromise case, where it's not even, they didn't hack anyone's email. They didn't hack into any system. They just know that your CEO's email address has an O in the name of it. And they change the O to a 0, and they create their own email on Yahoo or whatever, or go and purchase a domain that looks just like your corporate domain with a 0 instead of an O. And then they send you an email, and they send those out enough times that it's a low percentage, because it's not, a lot of people do catch that, but somebody is going to fall for it on a regular basis. And if they send that out 1,000 times and they get 10 people to hit, they're still making a bunch of money off of that. And so you see the wide variety. You see legitimate email compromises. And so the one we've seen a lot lately in Birmingham and Huntsville has been involving real estate closings. You have, it's obviously another target rich environment. You have real estate attorneys or title companies that are handling large dollar volume transactions on a regular basis. And those people all have very poor security on their systems. A lot of times it's not even something that they're thinking about. They need their email to work. They need whatever that mortgage type system is that they use to produce all of the paperwork and the signatures. They need that to work. And usually that's hosted by a third party and supported by a third party, so they never even touch it or see it. Those emails are getting compromised, and they're seeing that, hey, next Thursday, X ABC title company has 4 closings, and those closings are going to total $3 million worth of down payments. And so next Tuesday, I'm going to send an email purporting to be from the title company to those home buyers. And I'm going to tell them they need to wire transfer their closing funds to these certain bank accounts. And obviously these bank accounts are in Nigeria or Eastern Europe or wherever they're at. And because the home buyer has never met the people at the title company, it's a perfect storm. You're never going to meet them. The only time you're going to see them is when you go to closing and you sit down at that table with them for a couple hours. The person you interact with on a regular basis throughout that process is your realtor. And so it's not unusual for you to get an email from someone that you don't know that claims to be from this title company that your realtor told you you're using for closing or that you picked for closing, and they tell you to wire transfer money. That's been happening a lot for the last year or so in this area and really across the country. And it's for those reasons. It's a target-rich environment. It's low security, and there's a lot of money involved in it. And it's, again, it's a tough situation where it gets a lot of people involved in legal fights on the back end, pointing fingers about whose fault it is. But at the end of the day, your closing funds are gone, and they're gone to another country, and it obviously didn't go to the people you're trying to buy the house from. So it causes a bunch of problems. That has been going on a lot lately. The big one, though, and so the Ryuk stuff, ransomware is the one that we've seen the most of the last year. And it's getting, at first, when we started seeing it, it was literally click a link, encrypt your system, and encrypt whatever your system had administrative level access to. So if it had a share on a server that, for whatever reason, was misconfigured, and you had admin level access to that share, it would encrypt all the data on that server that was in that share as well, because you had access you really shouldn't have had on it. Those were bad, but weren't as bad as what we're seeing now. The stuff that we're seeing now, so with Ryuk, and then there's 2 or 3 other groups that are pretty sophisticated as well, they are using like Emotet, Trickbox. So those are older financial, so those are more malware that were being used back when Zeus was really popular. A lot of people didn't patch against those, and so they have fallen off the radar, and no one really was using them before. Now they're starting to pop back up. What that's used for is the initial foothold. So They will use Emotet or TrickBot to gain access to a system and then to do the recon inside of these large networks. And what they're looking for is, where is the most important data? Do you have any type of endpoint protection running on your system, or basically what type of, antivirus? There are people out there now that are paying lots of money to have anti-ransomware protection put on endpoints as well. So they scan for all of that. They want to know where your data is, what type of security you're running, and then also, can I get any of the credentials on your network? And this may take a week, it may take 3 months, whatever it takes is what it takes, and they're willing to do it. So they do all of this recon, and the payload is not on your network yet. They're not going to download the payload from their infrastructure until the day they're ready to execute it, so that just by chance you find it, or your system, your security protocols in place find it, you won't have time to do anything about it. We have seen them literally, these actors now, so it's gone from click a link, encrypt your system, and then whatever shares are, go from that level of sophistication to now they are searching for network shares that are backed up to. They're searching for credentials. We've seen them go to systems, so cloud-based backup systems. Go on those systems because they have the credentials, delete all the backups. Turn off the anti-ransomware protection on the endpoints. Turn off all the endpoint protection because they have the credentials there. And then encrypt the entire network. And then tell you they want $5 million in ransom. That type of stuff is what's going on now. And so it's really, really devastating to companies. Again, if you have offline backups, which is what people should, that's still part of very good hygiene with backups, you're probably going to be okay. It's still not going to be a good day, but if you do have a rotation of backups that are not stored anywhere on a network and they are stored securely off-site, offline, you could restore back to your backups. But if you don't have that, in a lot of the instances now that we're seeing with ransomware, the only choice is to pay the ransom and hope that they restore the data completely, because there's not much else you can do about that. So I got another question. So advice or guidance on people wanting to work for the FBI? Sure. So you have to have, I can't tell you, so I'm kind of limited in what I know about this on the support side. I can tell you what it takes to become an agent. On the agent side, you're going to need to have a college degree, so a 4-year college degree, and 3 years of professional work experience after you graduate college before you are eligible to apply. So that's the minimum requirement. If you get a master's degree, you can apply 2 years after you graduate with your master's degree. So those are your basic minimums. Once you get out of college and work, you would apply to the FBI. You're going to have to pass phase 1 testing, which is involving a little bit like an intelligence test and a little bit of a personality test. You pass that, you go to phase 2, which is a panel type of an interview with 3 agents there, and they're going to interview you to sort of see, do you meet the criteria of what we're looking for as an agent. You also will be polygraphed. And that polygraph is going to go back to your 18th birthday. And so the average age roughly that someone comes into the Bureau as a new agent is about 30. And so you're going to have that 18 to 30 window where you've gone to college, you've had a job, worked in a professional level setting for a few years. So there's this track record, right, of what you've done as a student, as an employee. When they do that background investigation, they're going to go back to your 18th birthday and they're going to talk to people related to anywhere you ever lived, anywhere you ever went to work, and anywhere you ever went to school. They're going to run your criminal history in all those areas. So the big thing is obviously stay out of trouble. Don't do drugs. All of this stuff is available on the FBI.gov website too. So you can obviously go there and look at it. But you want to make sure that there are automatic disqualifiers, that if you've done these certain things, you're not going to get in, and they will find it out through the polygraph and the background investigation. So you look at that. If that's what you want your future to be, I would encourage you to go look at that now and let that influence some of the decisions that you make while you're in high school. And then obviously as you move on to college, knowing that if I do A, B, C, or D, those are automatic disqualifiers for me, and I can never be an FBI agent if that's something that you're interested in doing. So after you would pass that background investigation, the polygraph, phase 1 and phase 2, you also have to pass a fit test, which involves max effort. So the first event is sit-ups, so it's max effort sit-ups, a 300-meter sprint, so almost 1 lap around the track. Then you would do max effort push-ups, and then a mile and a half. You have to get a minimum of 1 point in each event, and so that I think that grading skill's out there too on the internet. But basically, you have to have 12 points total to pass, and you have to pass every event. So you can't be a superstar in one event and get 10 points. 10 is the max you can get in any event. So you can't get 10 in one event and then 1 and 1 in another and have your 12 and say, all right, well, I'm not even going to do the mile and a half. You can't. You have to pass, and the passing standard is pretty tough. In saying that, a lot of you probably are listening and are like, oh, that's not that hard. And the truth is, it's not individually. But what makes it difficult is there's only 5 minutes of rest in between each event. And so if you think, I just did max effort sit up, so now my core is smoked. And then part of what they judge you on is suitability. And so if you're not giving max effort, they're going to ding you on suitability and you're not going to pass. And so max effort sit ups, so your core smoked. And then you run a 300-meter sprint as fast as you can run. And that's going to smoke everything in your legs. And then you're going to turn around and do push-ups, max effort. And so now your core smoked, your legs smoked, and your upper body smoked from doing as many push-ups as you can without stopping. And now you got to toe the line and run a mile and a half. And the first couple laps around that track, you're probably not going to feel your legs. And then eventually it will start to come back. But that's what makes it difficult. A lot of people do not prepare well enough for that. It's really just a gut check. I mean, if you do each one of those events max effort like you should, you're never going to just breeze through that fit test. It's kind of a gut check, and that's part of why it's designed the way that it's designed, to make it difficult, and you just kind of got to fight through it. But you got to pass that as well before you have to have a passing score on the fit test before they will send you to Quantico to new agents training. The big things that the Bureau is looking for right now are foreign language skills and technical skills. And so if you have a degree in any of the computer sciences, information systems, engineering, that type of stuff, that is going to make you the highest level candidate that we have. So you're most attractive or most competitive, I think is what they call it right now. Or if you speak certain foreign languages. And so any of the Arabic type of languages, Russian, Mandarin, those type of languages. If you have Spanish, probably not so much, but definitely, your Russians, your Mandarins, and your Arabics and things like that. If you have that type of a skill set, they would also, you'd be very, very highly competitive. Any other questions on that end, Neil? Mandarin, those type of languages. If you have Spanish, probably not so much, but definitely your Russian, your Mandarins, and your Arabics and things like that. If you have that type of skill set, they would also you'd be very, very highly competitive. Any other questions on that end, Neil?
I think that was the last question. Someone did mention the FBI.gov website. As far as for hiring, I think that would also answer another
Sure.
question
No
regarding the
problem at all.
difference
Yeah, just
between
like Neil said, I mean, it's
new agent hiring
they're not trying to hide
versus
anything from you. So if you have those kind of
professional or
questions or
support
you think
positions.
this is something that you might want to be a part of, go to the website and do some digging, because all the information's there, even on the support side as well. It'll tell you exactly what you need, what qualifications, degrees, all that type of stuff. It's all out there for you. Sure. No problem at all. Yeah, just like Neil said, I mean, sure. They're not Thanks, guys. From you. So if you have those kind of questions or you think this is something that you might want to be a part of, go to the website and do some digging, because all the information's there, even on the support side as well. It'll tell you exactly what you need, what qualifications, degrees, all that type of stuff. It's all out there for you.
Thank you much. We're going to take like a 5 to 10 minute break while I get the So I am trying to work out the audio as far as the little in-between announcements. Dr. Dolliver is ready. It took me a second to get connected, and we're good to go here. Dr. Dolliver is a professor from the University of Alabama and part of the Joint Electronic Crimes Task Force, as well as an FBI task force officer, and really big into cyber. So I'm just going to turn it over to her. And you should be all the way live. You're on the screen and your PowerPoint's up.
All right, thank you so much. Good morning, everyone, and I apologize for the slight delay. But I really appreciate the invitation to come speak with you guys today a little bit about my research and my work, and then some of the investigational challenges that we face in law enforcement today in the realms of digital forensics and different crime that are facilitated by different dark nets. So primarily the Tor network is what we'll be talking about today, but there are others out there that we should be aware of. So as Neil said, my name is Dr. Diana Dolliver. I am a cybercriminologist, an associate professor at the University of Alabama, Roll Tide. And I'm also the academic director for our Joint Electronic Crimes Task Force, which is located on campus. So I'll talk a little bit about that so you get an idea of kind of what some of the things are that we do. And then I'm also a task force officer with the FBI assigned to the Cyber Squad. So you can go ahead and go to the next slide, please. Good. All right. I got to do the same on mine. Okay, so I wanted to give you guys a little bit of background just in terms of sort of my work and what I do, so you'll get a little bit of a better context for who I am and kind of what this talk will be about. But because we have so many different challenges that we face in the realm of digital forensics today, you're really going to be hard-pressed to find any sort of crime that's going to take place that does not have some sort of component, digital component to it. So at the task force, we are a joint task force between law enforcement and academia, which is a unique kind of hybrid model that we have going on. So UAPD heads the task force on the operational side. So our investigators, we have sworn and civilian digital forensic investigators that are staffed with it. So, and then I run the academic component, and I myself am also a certified examiner at the lab. So essentially what we do is anytime any evidence is seized in the commission of a crime that has a digital forensic component to it, those agencies from around the state, and we've had cases come to us from out of state, they'll be brought to our lab and with the search warrant, of course, and then we'll extract the data from those different devices. So we essentially conduct dead box forensics, and so we'll analyze the data, we'll create our reports, and we'll hand all of that back to the investigating agency. So we're basically the data nerds that work with the devices as opposed to the door kickers that go in and collect the evidence for these cases. And then in my research capacity at the university and with the task force, and as well as with the FBI, I primarily study darknet criminality, so any form of crime that happens on the dark web, which is going to include the analysis of different cryptocurrencies, which we'll talk a little bit about, as well as it's going to involve the knowledge of and the use of different encrypted communications such as PGP, so pretty good privacy. And so I run an intel organization as part of my research at the university, and it's staffed with cyber intel analysts and then a slew of very talented graduate and undergraduate students that help me in the darknet research world. And then we also provide free training for law enforcement in these areas. So next slide, please. All right, so just a little bit of background about the task force itself. So our mission statement is to provide digital forensic services to all and any agencies that would like it. So we don't charge for our services. We provide this as a free service. And then we also conduct research on emerging technologies and currencies so that we can stay at the forefront of all of these different trends and changes, which is really, really critical in the law enforcement world today. And so we have, it's actually probably closer to $600,000 worth of equipment right now that's in our lab. So hardware, software, anything that we might need to extract the data from a multitude of different devices. So everything from cell phones to laptops to drones to Internet of Things to vehicles, PlayStations, Xboxes, DVRs, the list goes on and on. So we have at our lab on the operational side a number of full-time examiners, so both sworn and civilian positions. I mentioned our analysts. We also have state special agents, so ALEA, the Alabama Law Enforcement Agency. And then we also have Secret Service agents that are in our lab as well. So we are affiliated with the Secret Service, as well as ICAC, which is the Internet Crimes Against Children Task Force in the state. And then we also are affiliated with the NCFI, which is the National Computer Forensic Institute. And so the majority of the devices, even though there's a broad range of devices that we receive at the lab, the most common devices are going to be your cell phones, of course, and then laptops, external hard drives, and that's about it. So those compose the majority of the devices that we examine. And I mentioned before that we conduct primarily dead box forensics, so we extract data essentially when the device is either turned off or it's isolated from a network. So the data are essentially at rest on their storage device. So we are starting to get into more live network acquisitions, but we're still in kind of the beginning phase of that. Next slide, please. And so you can see in these pictures, the picture on your left, the left of your screen, is our dedicated training space. We actually have much nicer computers now, so this is a bit of an older picture. But we conduct law enforcement trainings. I teach a digital forensics undergraduate course in the spring, and I also teach a cryptocurrency investigations course. That is a new course that will be taught for UA students out of this specific training lab. And then you'll see the picture on your right is our dedicated research space. So both of these spaces are completely off-grid in terms of network. So we've got secure network connections, and we're ready to go from that standpoint. And then the digital forensics part of the lab, where we do our criminal investigations, we obviously can't show pictures of that space, but it's off to the left. So this is one big, essentially, task force that we have, that these rooms are adjacent to each other. Next slide, please. Yeah. Perfect. Is this stuck on a particular slide? No, you're fine.
Yeah, it's stuck on the first slide, and I apologize.
Yes, yes. Of course, that sounds good. So if they,
Will any of these slides be available
good.
after the talk? Is it okay if I just? I'm gonna try to.
You're good. So, excuse me. The reason that a lab such as ours is so important in this day and age is really because the landscape is changing. It has been changing for law enforcement agencies, and it's just going to continue to change and evolve in ways that we probably can't even kind of conceptualize right now. So from that standpoint, if you're interested in a career in law enforcement with a cyber component or a digital forensics component, you're going to be entering a very dynamic world that's going to require you to really stay on the forefront of all of these changes and to continue with in-service training and study these topics as much as you can as students now, because it's only going to come in handy more and more so in the future. But all of these different changes and the changing landscape and the moving targets, what these do is that these create new investigational challenges for these agencies. So aside from a lot of the different digital forensic challenges with regards to staying up to date with hardware, software, new devices that are being developed, some of those new investigational challenges also involve different mediums by which people commit crime online. And so those include darknets. So we'll talk about darknets in a minute, but there are multiple darknets. There's not just one. So the Tor network is going to be the most popular darknet that most people are going to be familiar with in some regard. But with that comes kind of new forms of transactions. So I have new in quotation marks on the slide because it's not new to us maybe as a society. So the birth date of Bitcoin, the Bitcoin white paper, is actually tomorrow on Halloween. So Satoshi Nakamoto created that first white paper conceptualizing Bitcoin on October 31st, 2008. So it's not necessarily super new, but for law enforcement, these are new challenges, and they may not fully understand cryptocurrencies in general, or how Bitcoin fits into that, or what the blockchain actually is. So those are new to law enforcement. And then there's also new forms of communication that are occurring in terms of things like pretty good privacy, so PGP, and being able to communicate in those mediums for the purposes of criminal investigations. So these are the sort of things that I stay up to date with my current research and the intelligence project that we run. So I'll kind of start diving into what a darknet is, what that means, and then clarifying a few terms, because there's a lot of misconception out there in surrounding the darknet. So it's a term, it's a sexy term, it catches people's attention and they want to know more about it, and then they also might be hesitant to interact with it just because it sounds scary. So just to kind of clarify what it is we're talking about, dark nets, so there's more than one, are platforms that are going to use anonymizing software to access. So to put it in perspective, when you use the Google Chrome browser, or you use the Safari browser, and you're Googling different things, or you're looking at different search engines like Bing, those search results that are returned to you are what we call the clear net, or sometimes you'll hear it called the surface web. So that's anything that's going to be returned to you on that medium. So that is going to be different from the deep web. And the deep web is not the same thing as the dark web. So make sure you're keeping those terms separate from each other, because the deep web is going to be anything that is on the clear web that is accessible through at least one layer of encryption. So if you Google Bank of America, so BofA.com, that's going to be the clear web. When you log on to Bank of America, that is going to be what we call the deep web, because nobody else can access that, hopefully, if your password is secure. Nobody else is going to be able to access your private information on the clear web. So that's the deep web, and that's what composes the majority of the internet as we know it. And that's juxtaposed to dark nets, which again are going to be any sort of internet platform that uses some form of anonymizing software, so that you either have to download and configure and things like that. So that portion of the internet is really what we're talking about in terms of anonymizing its users in different ways that we'll mention in a minute. So we'll talk about Tor. As I mentioned, it's the most widely used darknet that's out there. And Tor originally stood for the onion router. It was the concept developed in the 90s, the mid to late 90s, by 3 computer science researchers trying to figure out, is there a way that we can have secure communications online? And so that concept has been, it was developed, it was funded federally, and now we have the torproject.org, which you can go to. It's a website. You can download the Tor browser for free. And the Tor Project is currently a 503c nonprofit organization run out of Cambridge, Massachusetts. So I mentioned they are federally funded. Their funding was originally sourced from the U.S. Naval Research Laboratory, and now they're funded by the National Science Foundation and many, many other funders, both private sector and government. So in terms of the darknet and how it can actually keep its users anonymous, there's a few ways in which the Tor network does this. And we don't need to get too technical with all of this, but just so that you have a more general understanding of essentially how all of this kind of works. So the first way that the Tor network kind of anonymizes its users are that it's going to obscure their IP addresses. So in other words, if you went to your Google Chrome browser now and you typed in, or your search engine, and you typed in what's my IP address, it would reflect, unless you're using a VPN, it would reflect accurately where you're located. When you're in the Tor network, it doesn't work that way. So it's actually routing your traffic through a series of nodes to essentially obscure the originating IP address. So from that standpoint, we're unable to track users' behavior from site to site like we can on the clear web. So we cannot necessarily tell that you went to this Tor site, spent 15 minutes on it, clicked around, and then you navigated to site B, and then you navigated to site C. We can't see that on the Tor network. So in that regard, we cannot, as law enforcement, use IP addresses to identify any sort of darknet crimes that are being committed in specific locations. So like Alabama, for instance. Cool, awesome, thank you. So we're on the How Are Users Anonymous slide. Awesome. So hopefully you guys can all see the slides now. So as I was saying, we can't tell necessarily what the IP address is of that user. We can't use that information to identify the individual. So that's the first way. The second way is that Tor is not indexed. So the clear web is indexed because that's why we have these huge mega search engines. So there's web crawlers that go out there and they crawl the clear web, and then they basically make all of their findings searchable to us. So the crawlers can find pretty much anything that's out there on the clear web. We don't know how many Tor sites exist or what the content of those sites are because the Tor network is not indexed in that way. There is no Google for the Tor network. There's no way to search every nook and cranny of this network. There are individuals who have launched their own little mini indexers, or in other words, web crawlers, and then you can use their search results to search a small portion of the Tor network. But again, it doesn't really translate to the same concept. And then the third way that I'll talk about how users are anonymized are through the URLs. So this is an example URL. You can see it's 56 characters long. It's alphanumeric. It looks like nothing. It's essentially a hash of this website, but it anonymizes the contents of what's on that site because we don't know, we have no information essentially from this URL as to what the contents of the site might be. And I'll point out too that the length of the number of characters, in other words, for these URLs continues to grow. And that is another anonymizing feature because if we did launch a web crawler, it would it'd be very, 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 if not very, very difficult, if not impossible, to crawl all of Tor and try to get all of those 56 characters in and then move to the next site, So it's nearly impossible to expect crawlers to be able to do that in this day and age. So it's basically hiding the contents of that site from any web crawlers or from us. So in other words, we're not going to come across this site by accident. We will have to know essentially what the URL is to get us there. So next slide, please. Thank you. And so just to give you an idea of the types of crime that me and my research team have come across throughout the years, since I've been at the university for going on 8 years now. So we've been doing this for quite a long time. But you can essentially find anything from, there's drug trafficking, so drugs are very ubiquitous on popular Tor marketplaces. Again, since we don't know how many sites are out there on Tor and we don't know what the contents are of the hidden sites, and that's what we call the .onion sites, because you can access clear websites on Tor. So you can go on facebook.com through the Tor browser. So when we talk about these types of Tor sites, we're talking about the sites that end in .onion and are otherwise called hidden sites. So the type of crime, since Tor is not indexed, the hidden site portion of Tor, we don't know what composition, if it's 50% criminal activity and 50% just everyday people hosting sites on the Tor network. What we do know is that there's quite a bit of crime that exists on this platform. So anything from people offering malware for sale to carding sites, fake IDs. Don't do that if you're a student. Don't buy fake IDs. Assassination sites, poison sites, unfortunately, a lot of child exploitation sites, and things like that. And so they can be in the form of a marketplace. So that's the popular Silk Road model type marketplace, where it's kind of like Amazon or eBay is always a good analogy, where a group of people or an individual hosts a site and then others come and become vendors and have their own shops. But what we're seeing more and more is that actually that's kind of splintering. The larger marketplaces, like they did back in the day, don't necessarily exist as much in such a presence now. So we're seeing more vendor shops and smaller type websites pop up that are selling these types of items. And so with the Tor project, they make the argument that they're very much on the side of privacy. So they say, yeah, we know that there's lots of different types of crime that occur on this platform, but there's actually more legitimate uses for Tor that eclipse the criminal activity. So, for instance, if you're in a country like Russia or China that has an intranet, or in any other country that is going to restrict the types of websites you can go to, if you have the ability to and the access to download Tor, you now have that portal to clear websites that were once restricted, because that traffic cannot be tracked and traced, and your IP address does not accurately show where you are, that you actually have access to more clear web content. Next slide, please. So this screenshot is taken from, it says Silk Road, but it's actually Silk Road 2. And I just wanted to kind of show you what it looked like at one point in time back in the old days, back in 2014. So the folks who started Silk Road 2 in Silk Road, they kind of came from this mentality of they wanted to essentially post a manifesto of sorts to say, Silk Road is not a marketplace, it's a global revolt. The idea of freedom is immortal. So they had much more of an ideological stance and approach to selling different items and offering different things for sale and inviting people to come and be vendors on their site. What you'll see now is more of a utilitarian model where, hey, we're hosting a site. If you want to come sell your stuff, please feel free to. But the Silk Road became pretty much the standard model for a lot of these larger marketplaces. So you can see on the left-hand side, they break down the different categories of things for sale by drugs, alcohol, art, custom orders, which we can talk about if anyone has questions. But you can see there's a lot of different items for sale. What you won't see on here are, for the majority of it, on marketplaces, you're not going to find any child pornography. You're not going to find any instance of human trafficking, or at least explicit, blatant human trafficking. You also won't see many weapons for sale in marketplaces. And you can see that how old and outdated this screenshot was, because they don't have a ton of people selling stolen data, because that's become very popular now as data breaches become more and more frequent and commonplace. So next slide, please. And so this is kind of a little buffet of screenshots that I've taken from different sites that have come and gone over the years, just to give you an idea of other types of items that are out there. I'm sure your eyes were drawn to the organ trade screenshot that was at the top. You'll also find weapons for sale. There's, of course, drugs everywhere. You might see, this is one of the in the middle, it's polonium. Is that real polonium? I don't know. That's something that will have to be investigated at some point. So you'll see lots of different things being bought and sold. The value of it. So in other words, is it actually real? Can we validate that this is really a frag grenade that's being sold. These are things that law enforcement will have to kind of learn how to investigate on this platform. Please. And so in this slide, you can see, again, the Alabama fake ID, don't get a fake ID. But you can also see kind of a larger breakdown of the different types of drugs. You've got a little mailbox in the top left corner, because anonymous drops have become quite popular, or at least how to do some sort of anonymous drop. You can also, on these different sites, I've even seen those big metal containers for FedEx or UPS, the drop boxes that you put your package in, and then the FedEx person at some point in the day will come and pick it up. So I've seen those metal containers for sale. Not recently, but quite a while ago. And then uranium ore, again, probably not real, but you'll see a lot of the emerging types of drugs, so the new psychoactive substances, as they're being formulated in the lab and as they're being tested on the market, you'll start to see this pop up. And we see a lot of the new psychoactive substances originating out of China. Please. So how do you pay for stuff? So say you wanted to try out the uranium ore on Tor and you wanted to try to purchase it. So you'll see on some of the screenshots, you might have been able to see a cost or a price for it. And you probably didn't see the price that was listed in cryptocurrency. You probably saw the price listed in USD or the British pound or some form of fiat currency. But that's not how you actually make your payment. So if you want to purchase any of these types of substances or listings or whatever it is that you're interested in purchasing, you'll have to make your payment in cryptocurrencies. So as law enforcement, you have to understand, what the darknet is, and then you have to understand how financial transactions are conducted. So Bitcoin is still king. But there are over 7,000 different types of cryptocurrencies in existence. With that being said, Bitcoin has I think it's about 60%. It fluctuates a little day to day, about 60% of the market share. So many of the marketplaces, you'll see Bitcoin being accepted, but now you're starting to see marketplaces diversifying in terms of, if they'll accept also Litecoin or Ether. And they're even starting to move some marketplaces and just some Tor sites or hidden services in general to what's known as dark coins. So many people think that Bitcoin is anonymous. And in some ways, it can be hard to attribute a transaction to a person. But the whole point of Bitcoin is so that all of the transactions are public, and they're public in perpetuity. So which means that if I conduct a transaction and I send Neil 5 Bitcoin today, that transaction will be on the blockchain in perpetuity. Anybody can see it. So that part of it is completely transparent, which was the original intention for Bitcoin back in 2008. So with this, as law enforcement, we have to kind of start thinking about things in a little bit of a different way. Next slide, please. So all of this kind of leads us to the different challenges investigationally that law enforcement and other agencies are facing. And when I say law enforcement, I'm not only talking about the feds. We tend to think of all of these maybe criminal instances as operating at that larger federal level. But we're seeing this pop up in local and state cases. Local cases in small town Alabama are now dealing with individuals who are very savvy with the dark web and very savvy with cryptocurrencies. So this presents different challenges, including OPSEC, which stands for Operational Security. So in other words, how do we as law enforcement keep ourselves safe while we're conducting investigations? And then also, how can we conduct our investigations on this platform in the most efficient way, essentially. So to do that, we have to fully understand what cryptocurrencies are, or at least staying up to date on the different trends. We have to understand how to communicate with these different cultures that are on the dark web. And then we also have to understand how to take the information that we see and that we come across and that our intel analysts have gathered and learn how to deconflict the dark web data with what's on the clear web. And then also, of course, from a paperwork standpoint, knowing who to subpoena, and then knowing what information that you're likely to get back. And then I also wanted to just briefly mention, as we're kind of wrapping up, just some of the investigational challenges for digital forensics, because these two are not mutually exclusive, the dark net with digital forensics, because everything we do on a computer is going to leave fingerprints. We have digital fingerprints everywhere, all over the internet. So even though we're on dark nets, if you seize a suspect's laptop where they've been on the dark web, you won't be able to get their browser history, but you may be able to forensically image that machine and then pull forensic artifacts out of it, or off of it rather, that then allow you to seize cryptocurrency, for instance. So being able to recognize as investigators devices of interest on scene for local, state, and federal is hugely important, and that's a bit of an investigational challenge because Bitcoin and other forms of cryptocurrency can be stored on paper wallets. So it can literally just be a piece of paper. So if investigators don't know that, they're less likely to seize that piece of paper on scene that could have lots of money on it that was tied to criminal action. And then for the private sector versus law enforcement, for those of you out there who are students who are taking classes and you're thinking about your career moves, the private sector is going to pay you a lot more money than law enforcement, unfortunately. So it's hard for us to recruit the best and the brightest to come join our mission because we lose a lot of good students and a lot of good people to the private sector. But that's not to say that we don't have the best and brightest working for us right now. So that's kind of an overview. If you want to go to the next slide, Neil. That's kind of an overview of a little bit about the dark web, a little bit about cryptocurrencies, and kind of what I do at the university and with the FBI. So thank you so much for your time. And if you have any questions, I would love to talk with you further.
Dr. Dolliver, can you hear me right now?
I can.
I believe the whole feed can hear me right now as well. If somebody was in school, what would be a course of study, or what would a student pursue if they wanted to maybe just understand what you're talking about, but actually do what you do for a living, or get into the cryptocurrency analysis forensics field?
So that's a great question. So if you're a student, I would recommend having at least some exposure to different courses in computer science, but not just in computer science, because the academic field is getting very diversified now in that it's not just restricted to computer science. So I myself am in criminology, criminal justice, and I'm teaching classes in digital forensics and cryptocurrencies. So kind of think outside the box. There's also different classes in a lot of different universities that are in the business school. So management, information sciences that have invaluable courses for cyber students. And then I would do your homework and look at each individual program as you're deciding to go to college or you're deciding to transfer to different programs. Do your research and see what's available at those institutions. The Joint Electronic Crimes Task Force is unique. I believe there are, as of 2017, there was only 11 labs in the country that had that joint kind of hybrid model. So we were able to provide our students with unique opportunities through internships. We have a network intrusion lab internship track. We have a digital forensic internship track that we offer. And then through other programs in other departments like computer science and MIS, they have their own opportunities for their students. So I would say definitely do your homework and then talk to your professors as much as you can. So you can't bug us too much, because if it's about your future, you want to make sure that you're doing your due diligence to plan ahead.
And then one more question on here was, is it true that some people hire assassins on the dark web? There's plenty of stories and tales out there on the internet about it, but some of the stories sound kind of sketchy. Are there any stories that you can share or you know about that have to do with murder for hire?
That's a great question too. That's one that always gets a lot of attention, I think. So in terms of what I've seen, so this is the thing with a lot of these sites. So the murder for hire, the all the gory stuff that you'll hear about kind of in popular culture and things like that. A lot of that are just scams and kind of rumors, but there are some in fact that are real. So I can't talk about specifics with most of them except one, I think was, and you can Google this, but there was one case where I think it was the Hydra Marketplace where somebody had hired a hitman and then they were actually arrested for it. So, maybe 80% of it is kind of bogus or fake sites or scams, but there still are the smaller percentage that are real. So, yeah.
Right.
Please don't hire any assassins online.
Yeah. I think and then there's one more question on here too in terms what asked about Signal. So what percentage of local crime would you say is using encryption tools like Signal? Can you speak to that at all?
Yeah, I can speak to that a little bit. So Signal is an app on your phone that many people use. I have it on my phone, my personal phone. So these are like WhatsApp, Telegram, all of these kind of end-to-end encrypted applications. We do see many people using them. I can't speak to necessarily whether one's more secure than the other, but there are definitely these applications definitely have a presence within the criminal community, but then just the whole privacy-oriented community. So just your everyday person generally tends to know about encrypted apps on your phone. iMessage itself is end-to-end encrypted. So technically it's also more of a privacy type application. However, with iMessage, when you image a phone, you're able to pull a lot more data than you can from certain standalone apps. So they kind of vary in their capabilities as well. I think WhatsApp is owned by Facebook, so do with that what you will, but many people do use those type of applications.
I think we'll end it there. Thank you so much, Dr. Dolliver.
Yeah, thank you. Thanks for having me.
The next talk is at noon, probably a few minutes after noon will be Snowflake. We'll do a presentation, and I'm going to put my
Okay. Okay. Okay.
Now, if you can hear me right now, this is Neil again. We're about to start the lunchtime speaker and sponsor today as well. I believe we have some door prizes and stuff to hand out that are because of them. Snowflake is going to talk. We have 3 different presenters: Ryan O'Connell, Shannon, and then the third name, I'm drawing a blank right now, Jason Shull. I'm sorry. So I'm going to turn it over to them.
Awesome. Thanks, Neil. Thanks, Neil. Thanks, everybody. Thanks, everybody. Thanks, grabbing your lunch real quick, grabbing some time with us, learn a little bit about how Snowflake and data analytics and how Snowflake is being used in a way a lot of us don't really know. If you're unfamiliar with Snowflake, still relatively new. It's software IPO history, at least from an Alabama news, we're starting to make why I'm here. So we're going to be able to walk you through a lot of texture, why the IPO generation growing as fast, and then also be able to give you security, the hood with Ryan O'Connell. So my name is Shannon Taylor. I'm a sales director for Jason Shull on the call. He's our solutions architect and engineer, and also Mr. Ryan O'Connell, as I mentioned. And so we'll get into some of the beginnings here around what would you do with Snowflake? Why would you use it for data security and for data security lake? Where does that all kind of come together? And yeah. No problem. Check. All right, guys. Well, sorry about the echo. We'll dip into a little bit here on how Snowflake is used for really 3 key use cases. And to give you an idea of kind of what Snowflake does, we are at its main level a SQL custom purpose-built database in the cloud for OLAP or analytical workloads. That really is the guts of what Snowflake is. It really then comes down to how we were purpose-built for the cloud, not just lifted and shifted, not just running in the cloud, but actually purpose-built to take advantage of the scalability of both infinite cloud storage and infinite access to compute resources, and the ability to dynamically change those compute resources on the fly, as well as to isolate workloads by user, by department, by job. So everybody has just the right amount of compute for what they're looking to do at the right time. And no one singular job, be it loading data, be it querying data, be it accessing with BI tools or AI or ML tools or security tools, would bog down any kind of system or cause constraints or any kind of concurrency. So this just gives you a little bit of an idea from a security perspective. As I mentioned, Snowflake has really revolutionized the data and analytics space, anything from an OLAP workload perspective. So the traditional use cases for Snowflake would be data warehousing, data lake, data engineering, data pipelines. A lot of companies then run their applications that are built on Snowflake. The one that we would probably know here in Alabama the most would be Shipt, based in Birmingham, that runs on Snowflake under the covers. Also looking from that perspective into data science, the ability soon to do that native code execution of R and Python and the notebooking capability from a consolidated perspective, all in one singular platform. So those are the kind of the more traditional use cases, along with our data sharing capability, which makes us very unique. The ability to share data between Snowflake accounts without copying data. So therefore, the incidents for governance and provenance is very well taken care of. And the security risk has really dropped since the data is never actually copied. There's no managing of SFTP servers. There's no managing of API keys. There's no managing of even bucket security. Because as we know, nobody wants to be the next Equifax, whether it's vulnerability management or just access to buckets in general. Snowflake takes care of that and allows data to show up in your environment that's always live and always analytics ready. So there's no need to do any ETL or data wrangling, whether that is customer data, product data, inventory data, or security data, which we'll get into here in a moment. So we've really kind of raised our perspective in terms of our customers that are using us from a security perspective. And the genesis of using Snowflake for security started internally at Snowflake. Snowflake was growing so rapidly. Even though we had SIM tools, we had EDR tools, we had those for on-prem and cloud, even though we're primarily a cloud-based company and are pretty cloud native, having been founded in 2012 and hitting the market in 2014, we found a couple things. One, we couldn't overhire to actually get ahead of the issues that we had. And with all of the data and all of the cloud instrumentation that was out there from a security perspective, we also couldn't manage all those things, and we needed to automate processes. So that is really where Snowflake turned inward, and then we started looking at ourselves for how could we use Snowflake to manage threat assessment, to manage security metrics, and also to manage vulnerability management. And that really is the three key things that you see Snowflake being used for from a security perspective. So you see here some very popular names of folks that have been using Snowflake from a security perspective. It's very, very well vetted. And we are now starting to develop our own ecosystem, as you'll see here in a moment, of actually cybersecurity hunters and cybersecurity tools that are running natively in Snowflake. So if you're looking for even to offload more of your processes or looking for more native execution in Snowflake of security tools, that ecosystem is growing bigger and bigger every day. So the basic idea of Snowflake is to be able to bring in one single source of truth. And I know this comes up a lot, but it really is what Snowflake does. The ability to infinitely load data into cloud storage and to do it at a really economically viable price. So unlike SIM and EDR tools that really monetize the cost of data and data retention at a very expensive rate, either by gigabit or hundreds of thousands, if not millions of dollars by terabyte, which really limits the historical view of data that you can have. Most organizations that I talk to keep usually 30 to 60 days of SIM data, be it IP range, be it user, be it asset inventories, be it EDR alerts, log data, trying to look towards IOC events. Keep that 30, 60 days, perhaps, maybe 90 days if they have to pay more for even more cold storage, so to speak. But there really isn't a very long, holistic, historical look at data. So being able to grab a lot more data for the instrumentation that's out there, because also we find that about 70% of security data is not even being captured and definitely isn't being analyzed, usually due to the cost and also due to the complexity of 10s, 20s, 30 different systems trying to be integrated into the SIM, which was never really designed to be the integration hub. It's not an analytics platform. Snowflake actually is. So actually having storage at $23 a terabyte per month, compressed times 5, allows you to store a whole lot of data, infinite amounts, and to do it really, really cost effectively. So that way you don't need to worry about how many days out are we, or can we drag this source in. Financially, it's really not much of a concern. And the idea there is to be able to cut through the noise, cut through the false positives, to have better, faster investigations into threat assessments, to make sure that those detections are much more accurate in scale and also in terms of what you can search across, also bringing in other data sets that maybe you're not today from a security perspective, other business data sets that are maybe of more structured nature that are elsewhere in your organization, like, for example, HR data. We have a lot of organizations, one of the first use cases is be able to bring in 2-week notice data or termination data or user deprovisioning data to make sure that that's correlating well with what they're seeing from an alert and an assessment perspective, to make sure that they're on top of who has access from a vulnerability management and who should and who doesn't have access, and where, if any exfiltration occurs, where does that occur? And then also from an ongoing basis, once you actually have all the data and you're able to measure these things, what's getting better, what's getting worse? Well, if you can't measure it, you have no idea. So being able to automate those metrics, because they're very manual in nature, being able to automate those to the BI tools you have today, also being able to automate those to some of the insights we have in Snowflake through our analyst interface called Snowsight. But we see this a lot with our customers. We do it ourselves in Tableau and Power BI and Looker and MicroStrategy and any other BI platform that you can think of. The ability to automate those are right there. So that's really what we mean when we talk about a single source of truth, loading all structured data, loading all semi-structured data, and that would be your logs, that would be anything XML, JSON, Avro, Parquet, ORC, MQQT of sensor variety, GIS spatial data, whatever that may be, being able to load that directly into Snowflake, and then soon also having the ability to load unstructured data, which is right now in private preview in Snowflake. So probably early in 2021, you'll see the support coming to be able to load files of audio and video variety, straight text, PDF, Word, documents, PowerPoints, what have you. Also having that capability from a scanning perspective. And I'm going to hand this over now from an architecture perspective to Jason Scholl, my solutions architect, and he's going to get into some of the details on what makes Snowflake so unique. So you've got this great storage cost, that's great. You've got unlimited compute, fantastic. What about everything else? What about optimizing transactions? Do we have an index? How do we load the data from a partitioning perspective? Who handles security and governance? What do we do with metadata? How can metadata be used to actually do more investigations and search more data? And then how do we manage all this, as I mentioned before, from a sharing and collaboration perspective? What does that look like? It really is all down to the architecture. So I'll hand it over to Jason to kind of walk you through that. Jason, go right ahead, sir.
Thanks, Shannon. And I'll apologize to the group ahead of time because I do need to drop at the bottom of the hour, but you are in excellent hands with Shannon and Ryan. Know they can answer any questions that may come up during my portion of the presentation. So I have a data background. I was employed by Oracle, which is where our founders actually came from before I came over to Snowflake 2 years ago. So I'm going to focus a bit on this deep dive right here on how Snowflake is actually put together. And then I'll pass the reins back over to Shannon and to Ryan. So Snowflake's architecture is actually very simplistic. There's only 4 main components of the architecture. First, we start with what's called the cloud agnostic layer. So Snowflake was purpose-built on the cloud to be a cloud native and data platform. And since then, as Shannon mentioned, we've been adding other workloads, and we're also working on a transactional processing database at this time as well. But since we were built on the cloud using commodity cloud services, it means that we are portable to any public cloud. We just happened to start out on AWS, but we were later ported to Microsoft Azure, and then the end of last year, we were ported over to GCP, or Google Cloud Platform. So it's really up to you as to which of those 3 major cloud providers you want to run Snowflake on, or even if you want to run on a combination of those cloud providers. You can run in multiple regions. You can run on multiple cloud providers. You can fail over between them. You can share data between them. You can query across them. So it's very simplistic. We're open from a tooling perspective, a cloud perspective, so that you can use what you want to use, when you want to use it, where you want to use it. The next tier of the architecture is what we call our centralized storage. This is the foundational layer of Snowflake. Snowflake was originally built on Amazon S3. The founders coming from the Exadata team over at Oracle, reporting directly to Larry Ellison, they found that Oracle customers were not very happy about paying $100,000 a terabyte a year to run Exadata machines. And so when they left Oracle to build Snowflake, what they did is they said, let's make a data solution that brings the best of the data world into one purpose-driven platform and leave all the bad behind. So what if we can make Snowflake, $23 per terabyte instead of $100,000 a terabyte like Exadata? Well, that would really level the playing field. And what it has done is it's made Snowflake the most cost-effective data platform available on the market today, on premises, and in the cloud. We use the centralized storage for 2 purposes. First, we use it to land the data in an extended data lake architecture. Second, we use the storage for our micro partition. So once you ingest the data into Snowflake, we auto partition that data for you. And so we organize that data in 16 megabyte, 4 to 6x compressed increments with nothing for you to manage on the storage side. So that's it for the storage. If you need to use storage from outside of your Snowflake environment, you can reach out to AWS S3 external storage, as well as GCP storage and Azure Blob or ADL List Gen 2 storage if you need to, or a combination of any of those 4. So the second tier above the storage is actually the feature that attracted me over to Snowflake from Oracle. This is something that Snowflake is doing that no one else is doing. It's called our multi-cluster compute. This is how we isolate our workload. So you can assign just the amount of compute you need to get the job done, nothing more, nothing less. So that really means what we can do is we can elastically scale the compute to whatever size you need on the fly. If there was ever going to be a wait event within the system, what will happen is we'll spin up an equal amount of compute in order to handle that wait event so that there are no challenges whatsoever. With queuing or anything like that, we'll just execute that job and then turn that compute off automatically. All of this compute turns on and off automatically as you do things with data, like ingest data, query data, update data, etc. When you're not using it, you don't pay for it. It turns off. I was speaking with a customer yesterday in Middle Tennessee, and we were doing a go live review from a week ago where they just cut over almost 2,200 users across the country, and they said they had zero issues. They were running an IBM appliance before, and they are absolutely elated with their performance. The worst performing queries they have on Snowflake are running at less than 30% of the time of anything on IBM. So they are very, very excited, and they're also spending a very small fraction of what they were before with IBM. Above the multi-cluster compute tier is really where we have, the bread and butter of Snowflake. This is where our founders spent the bulk of their time making Snowflake the opposite of Oracle. So there's not thousands of parameters for you to tune and maintain. Snowflake actually optimizes and tunes itself. And we have the advantage of looking at is used across 3 clouds, across multiple regions all around the world. And so what we hear our customers tell us is, I throw more workloads at Snowflake all the time, and it just keeps getting faster and faster. We hear our customers tell us that year over year, even if they're running the exact same query, that they see the next year it was running way faster than the previous year. So we love hearing those types of stories, what's helping drive the adoption of Snowflake. Snowflake, it actually manages itself. And so every tier that you see of the architecture here, it's available all the time. It's triply redundant across a region in the cloud. That means that if a data center were to go down in a cloud region, you'll still be up and running, and you probably won't even notice any kind of performance degradation or anything. It is a multi-tenant environment. However, because we're isolating the compute and the storage to your specific workloads, there's never any problems with noisy neighbors or anything like that. And you don't even have a noisy neighbor problem for your own organization. The environment is always transactionally consistent. We don't allow any dirty reads. I'll save the security and governance piece for now and let Shannon and Ryan speak on that. But the second favorite feature of mine for the architecture is what we call our metadata manager. Snowflake does not use indexes, and that's because we don't need them. The metadata manager has block awareness of where the data resides in those micro partitions that I spoke of a few moments ago in the centralized storage. So the metadata manager, what it does is when you insert data into Snowflake or you need to update that data, if you update that data, we had written an immutable block of data in those micro partitions. And so the update moves a metadata pointer from the old block of data to the new block of data. And this enables some other capabilities that are also unique to Snowflake. Now you can query the data in Snowflake as it used to look up to 90 days. This is what we call time travel. And you can you can set up zero copy clones at the object level or all the way up to the database level, which is really just a metadata copy. So if you need to update the data in the second copy or the clone, which isn't really even a copy at all, then what we would do at that point is we create a branch in the metadata manager, and then you would be able to maintain just the deltas at that point. And actually, you're not maintaining anything because Snowflake's doing that for you. But saves a lot of money in storage, especially for very large environments, to have zero copy clones being used for those non-prod environments. We do recommend setting up separate compute resources and separate security for those non-prod environments, even though all of them can be housed inside a Snowflake without having to buy extra resources or extra Snowflake environments. The last thing I'm going to mention in the cloud services layer is what we call our sharing and collaboration. And this is really what is the backbone and what enables the data marketplace to work. And so we have what's called the private data exchange, the public data marketplace, and private direct sharing. Shannon mentioned earlier in the presentation that we have the ability to uniquely query data across the 3 cloud providers without moving that data. So SFTP downloads and uploads essentially go away. You have a secured view of the data, only what you have access to, nothing more, nothing less. It's completely governed and secure and completely in your control if you're the data provider, and if you're the data consumer, it just shows up in your environment with nothing for you to do. This became very, very popular during the COVID-19 shutdowns. We just had a few data providers on our data marketplace at the beginning of March. And a few weeks ago, we announced that we have over 100 now. So there's new tiles of data providers showing up each and every day, and many of them are in the security space.
Awesome.
So I'll stop right there and then pass it back over to Shannon to continue on with the presentation.
Yeah, Jason, quick question. I know that showed up in the chat. I think you or I maybe couldn't see it yet, but I know the answer came back around, the question came back around FedRAMP. And so, yes, we are FedRAMP moderate, working towards FedRAMP high. And we're also have reciprocity to CMMC level, maturity level 3. So we're working towards high. We're getting there. We have several large sponsors, including the Air Force and Center for Medicaid and Medicare Services, that really brought Snowflake into the FedRAMP process. Quick question, Jason, popped up around costs around the Splunk cloud versus Snowflake. Mm-hmm. Anything you can share there based on what you know?
Yeah, I'm not exactly familiar with Splunk pricing, but I do know how they do their sizing. So usually in the Splunk cloud, they look at compute cores per 10 terabytes is their increment. And so their guidance on ingestion is about 4,000 cores per 10 terabytes, which I'll be completely honest with you, that's an obscene number when I compare it to what we can do with just a few cores in Snowflake. So I've got some very, very large customers that I'm working with across 3 states and running analytics on huge amounts of data, some in the multi-petabyte range, and even ingesting up to 10 terabytes an hour. And most of them are not using anywhere near that amount of compute to pull it off. So it's my understanding that Snowflake, for companies that have chosen to replace components of their Splunk on Snowflake, are doing it because they're just saving an absolute fortune doing it. Some of those customers that were shown on a previous slide have actually completely replaced Snowflake. Replaced Splunk with Snowflake. We internally run Splunk, and then we offload a lot of the the older data onto Snowflake because of the tremendous savings that we have in the per terabyte. So $23 a terabyte, and it's usually 4 to 6x compressed. Pretty good savings there. So again, from what we've seen from on-premises solutions, depending on what the workload is, most of the time we see at least a 600% savings right off the top. For cloud replacements, we usually see 50 to 80% savings right off the top.
Yeah, and if I'm this is Ryan, I think that speaks to a common pattern, right? So even customers that are leveraging Splunk today, as their SIM, some of the data, they have some of the data some of the time, right? So some data might also be sitting in an S3 bucket or something like, Hadoop. And so there's this fragmented landscape, right? And the benefit there from a Snowflake perspective is consolidating that data in a single place. And I to echo Jason's comments around cost, I just know that from a storage perspective as well, it's pretty prohibitively expensive to keep all of that data in Splunk.
Yeah, and just to give you an idea from a credit perspective, list price, our compute resources, those virtual warehouses, what you see there in the multi-cluster compute, we have them in t-shirt sizes from extra small, small, medium, large, up to 6XL. And every time you move up to the next size, we double the amount of compute, which also doubles the performance. So if you had a query running in 5 minutes on an extra small, it would run in 2.5 minutes on a small, right? And then thus and so on. And to give you an idea, at list price, a small warehouse, which is 2 nodes and 16 virtual CPU, costs you $2 an hour. So pretty dramatic difference in cost, not only on the storage side, but also on the compute side versus what we've seen from other SIEMs in the cloud, which is kind of what's sparking a lot of folks looking at Snowflake from a security perspective. Not to mention also the automated JSON parsing, right? Being able to take a lot of the ETL wrangling out of those semi-structured data sets, which I know can take a lot of time and effort. That's a huge advantage too when loading data into Snowflake. Getting further here to just some architectures. This just shows a little bit more of what many folks are doing to get data into Snowflake. I know that Jason mentioned Snowpipe. That's our Elastic utility. It's really the only real-time Elastic data utility in the world that automates itself, not only in terms of ingesting data, but also ingesting it based on the compute that's needed for that time, scaling up to handle as much data as you possibly need, and then turning off, right? And that's the benefit of Snowflake, is you're only going to get charged for what you run when you run it. So it really does become Uber in that sense, that if you need to run a sedan for 5 hours, go ahead. If you want that answer much faster, run a semi for 30 minutes. If you need a fleet of semis running for 17 seconds, you can do that too. Or you can run a scooter all day, all night for 24 hours. It's really up to you. You get to decide what that looks like. And each individual SLA, each individual business case, each individual user has that ability. And we also have guardrails around the environment so that you can really control what resources are being used, as well as role-based access and very granular look down to the row level of who can see what in terms of data permissions, as well as dynamic data masking to blur, to mask, and to obfuscate data that does not need to be seen, as Jason mentioned, especially in non-prod, test, dev, UAT environments as well. So we have a lot of partners that we're seeing more and more folks work with. As I mentioned, that growing ecosystem of folks that are now offering end-to-end security solutions running natively in Snowflake. We just added Vulcan Cyber to that field last week. We have Panther, Obsidian, Hunters.ai, as well as another organization called Elysium that I'm pretty familiar with, that offers solutions to even go further to run native SIEMs, if you will, in Snowflake with still that elastic capability, but still always the ability for you to bring data in from any source, load it into Snowflake, be it relational structured data or semi-structured data, and then be able to query it using basic ANSI SQL and an analytics platform with infinite scale to get the answer back when you need it, as fast as you need it. So the things that we see people using, as I mentioned in the beginning, would be incident response, being able to look for a security breach, looking through a lot of historical data, because that really is the thing that we find people lacking, having a lot of context, making decisions quickly out of logs, but not really seeing the full scope of maybe what's going on, or also the full implication. It's one thing to know that maybe a bucket was accessed, but if that bucket corresponds to a customer, what customers would be impacted? And to be able to go through a CloudTrail to a bucket, to be able to see all those things, that's really valuable to understand the scope and be able to reach out to customers to figure out what could possibly have been impacted. Threat hunting also allows you to different data sets and a lot of context, as I mentioned, around HR data and other types of data to be able to really understand what kind of threats you're looking at, and then being able to measure all those things and understand what's getting better, what's getting worse, and having always fresh live data to report on. This is something that Snowflake has really done a lot of work on internally, and would love to be able to set up time with any of you if you have questions to be able to see these metrics and see where we've come from and what we've built and how we do this ourselves, because we don't just make the Kool-Aid, we drink it too. To that extent, I'll pause for a minute because I think you may have a lot of questions too around, okay, that sounds great from a solution perspective. I like everything I'm hearing, but tell me more about the security of Snowflake. I've never heard of this thing. And what could we do, from a Huntsville perspective, from a security perspective? Is Snowflake up to snuff? And what does that look like? So for that, I want to hand it over to Mr. Ryan O'Connell, who's our CTO of Field Security, former Naval Intelligence Officer. Questions a little bit about what's under the hood at Snowflake, what makes us unique, why is security and governance a key part of everything that we do and really the first step of the process, and really how we've been able to grow with the credibility, whether it's financial services, whether it's healthcare, whether it's aerospace and defense, to be able to provide that confidence that your data is safe and secure. So Ryan, please go.
Right on. Thank you, Shannon. Appreciate it. Howdy, y'all. Again, my name is Ryan O'Connell, so security architect focusing on all aspects of security at Snowflake. And yeah, thanks for the introduction there, Shannon. I was actually in Huntsville last November for a wedding, so have some family that lives in that area. Good to be connecting with y'all today. So as it was previously mentioned, right? Snowflake it's a SaaS offering, right? And that immediately implies a couple of different things, right? So when we talk about software as a service, it gets into, in industry recognized term, that's referred to shared responsibility model, right? So from a software perspective, that's everything that our customers can do to secure the front door, right? Throw another bouncer at the front door. You are able to configure that uniquely based on your own internal security controls. And then the service aspect is everything that Snowflake does to provide a highly available, secure performance solution. So let's peel that back a little bit. A couple of notes, right? Just right out of the gates, right? So along that shared responsibility model, right? So in our case, our customers are responsible for things like creating and managing users, deciding what data to load, what data to export, what commands they'll execute, right? And then Snowflake as a service is going to be processing those requests, maintaining that security, managing capacity. It is important to understand, right? Snowflake personnel do not have access to unencrypted customer data. Snowflake personnel do not collect, delete, update, disclose, or use customer data, period, right? So as we mentioned, we are cloud agnostic, so you'll be provisioned on Google Cloud, AWS, or Azure, and all data is encrypted at rest out of the box. So as we look at this slide, really when we talk about software as a service, the first three steps, right? Access, authentication, authorization, that's really the service or the software aspect, right? What can you tailor and configure uniquely to meet your own security requirements and controls? And as we move deeper and deeper into the platform, sequentially, step by step, moving from access, authentication, authorization, then you begin to get to the service side of the house, right? So moving into data and infrastructure. Now, what's interesting is you can still influence what happens at that data layer, right? And we'll talk about that a little bit more with some of the options on different editions of Snowflake and what's available to do things like bring your own key, for instance. I will highlight, before I kind of walk through each of these steps sequentially at a high level, you might have noticed, and it's already been asked, someone asked about FedRAMP, right? But you might notice the logos on the bottom left corner or the operational controls in the top right. So those are uniquely Snowflake achieved, right? We're not piggybacking and leveraging certifications or attestations that our infrastructure providers may have achieved, right? These are unique to Snowflake. So things like ISO 27001, our SOC 1, SOC 2 audits, things like HIPAA, PCI, and FedRAMP. And once customers are under NDA, right, certainly make these things available to our customers at their request. Although you can go out and check out the Snowflake security policy and the Trust Center, right, for other types of documentation. That's all public facing, and certainly encourage you to do just that. Now, when we talk about access, right, please understand, first of all, all traffic, all customer traffic is encrypted via TLS 1.2. We actually enforce a common connection pattern for all Snowflake drivers and connectors. So that could be, something like an ODBC driver, JDBC, even the web UI, right? We're going to enforce a common connection pattern. So HTTPS, TLS 1.2, all data is encrypted out of the box. But then we're also going to enforce other things at runtime, like perhaps you set up network policies, right, to restrict traffic to a known set of good IP ranges, or specifically block traffic from ranges that you don't want to have access to Snowflake. And certainly, also at runtime, right, there's no concept of an unauthenticated user session within Snowflake. So it's going to enforce authentication as well. So with access, some customers will want to bring in private networking technologies, and that's fine. We can integrate with those types of things. So things like AWS Private Link or Azure Private Link, we can integrate with those. But these are things that are within our customers' control, right? To begin to shape and scope where they will accept connections from through network policies, or take it a step further to do things and integrate with those cloud service providers' private networking capabilities like Private Link. So that's the access piece. As you move into the layer, another layer deeper into the platform, right? So I've begun to shape and scope where I'll accept connections from. The next piece is really, how do I authenticate my Snowflake user population? And really, with authentication, I think one of the things is around standards, right? So you'll recognize some industry recognized standards, right? So things like TLS, things like Jason alluded to, right? ANSI SQL, right? So ANSI SQL compliant. SAML2 for single sign-on and federated authentication. Things like OAuth as well, right? So there's emphasis on industry standards. But when we start talking about authentication, many of you are probably familiar, right? You've got to provision users within Snowflake, and certainly a common pattern in the SaaS world today is to do that through SCIM, right? System for Cross-Domain Identity Management. So provision users via SCIM, very common pattern to manage that user and role life cycle from a centralized place. Could be something like Okta, Azure Active Directory. Certainly. Users, if you go with username and password, are subject to the Snowflake password policy and enforcement. We have strong authentication mechanisms as well. So we actually have Duo implemented as part of the Snowflake offering. So if you're going to use username and password, you can take advantage of that Duo implementation to enforce multi-factor authentication. But many customers, right, want to go with, as part of their federated landscape, federated authentication for single sign-on. We certainly support that via SAML2. And as well, we support other scenarios like key pair with that private and public key. That is, often best used with a secrets management solution, something like a HashiCorp or something like that. But certainly a common scenario in the programmatic. The programmatic scenario where you have something that no human intervention and you need that programmatic access. Key pair is certainly a strong option, as well as external OAuth. Kind of the next step in is, we've talked about scoping and shaping access, where you'll choose to accept connections from. We talked about, okay, now how am I going to authenticate user populations? And that is often broken down by human interactive use cases as well as programmatic. Now, once they're there, what can they actually do within the solution? So now we're really talking about authorization. And with authorization, it really comes down to role-based access controls, that who can do what on which set of data. But I think there are a couple things that are unique from a Snowflake perspective when customers think about RBAC within the solution, and a lot of that is predicated on what Jason mentioned around the architecture. He made a strong point to talk about how we decouple compute and storage, and that manifests itself in our RBAC model as well, where you can get very granular in terms of granting entitlements to specific warehouses, and that might be warehouses of a different size. So when Shannon mentioned the t-shirt sizing, right, extra small, small, medium, large, extra large, right? So where this becomes interesting is customers oftentimes will grant entitlements. Maybe there's a division that uses Snowflake heavily, right? So they might be granted entitlements to a larger warehouse, and maybe there's a smaller division that doesn't have that requirement. So you can actually help shape some of the operational and cost controls that are associated with that just through the RBAC model. But it gets very interesting from that perspective. Another unique thing is within Snowflake, every session has its own unique context. So when I log in and there's a context associated with that session. That might be my role as an analyst. But if I want to change roles and escalate privileges, essentially, I actually have to change the context of the session. So now I might go from analyst to sysadmin. I have to change that context of the session. And that brings up the next topic, really, that often comes up from that perspective is, hey, can I see what happens there? And the answer is yes, right? Full audit trails for every action any user does. And those are stored within the solution in a tamper-proof container. And so, there's that expression, right? If you expect it, inspect it. This gives customers the ability to go in and look at things like login history. Query history is a popular one, right? Modifications to network policies. All of that is visible for customers. And then certainly we support common patterns of exporting that, right, to a SIM. And I know there's been some questions around Splunk, but more and more what is becoming common is customers are using Snowflake as that security data lake, right, as a central repository for all of their data. So the Snowflake data is there, but then they're bringing in other data from other sources to then layer on some of those analytics or some of those partners that Shannon talked about, Hunters AI, Panther, those types of things. So it becomes very, very interesting, very compelling. Authorization is really all about, minimizing access to data, and it was already mentioned, right? But certainly we have dynamic data masking from that column level security that can do those types of things, which becomes interesting when you're trying to minimize access to data based on a specific role that a user is using at a given time, which becomes powerful from a governance perspective as well. Now, that's really, again, at a high level, the product security features that are available for our customers to configure uniquely to begin to lock down Snowflake as they see fit. Again, and that could be based on your own internal security controls or perhaps different industries, federally regulated industries, healthcare space, those types of things. Certainly all part of that. Moving deeper and deeper into the platform now, when we talk about data, I mentioned all data is encrypted at rest. That is turned on, and you cannot turn that off, right? So all the great things you've heard about from a performance perspective and the things that Jason went over around being highly performant are all happening even with transparent data encryption at rest, right, turned on for the solution. We do leverage a 4-tier key hierarchical encryption model, right? Key model, right? And that's certainly, that rooted in a cloud HSM. A couple of other interesting things from an encryption perspective that really round out a healthy encryption strategy. We do support automatic key rotation. That is also delivered out of the box, right? So table master keys, count master keys are automatically rotated. And again, that's transparent to our customers. We also offer the option for, and I stress that it is an option because it's something that has to be set and turned on, but for yearly rekeying. So going in and rekeying all the table master keys, anyone that survives longer than a year, those get rekeyed. And then I had alluded to it before, certain editions, so business critical edition or higher on Snowflake, we have a feature that's referred to as Tri-Secret Secure. And in this scenario, customers can bring their own key. And so we now take what is an account master key on the Snowflake side of the house that's unique to a customer account, and we create a composed key with the customer's key that they keep depending on the cloud service provider, right? An AWS KMS or an Azure Key Vault. And then the other feature that is worth talking about, there's this concept of time travel. So time travel is something that a customer can control, and it sets data retention capabilities from 1 to 90 days. So the ability to go in and essentially see like a Control Z button for someone dropped a table, those types of things. You can go back and you can set those days from 1 to 90 days. The last piece is fail-safe. That's a 7-day window, but that is really more on the cloud service provider, whereby we can go in and recover that data for up to 7 days, and that's delivered out of the box as well. The last piece is infrastructure. That is to say, we don't have any, right? We rely on our cloud service providers. So we rely on, this slide has AWS up there, but it could be Azure or Google Cloud Platform. AWS physical security, Jason had already talked about the redundancy and the availability zones or availability domains. And then certainly as it pertains to, data compliance and things like that, choosing a regional data centers that makes sense based on if some customers have certain requirements. My data has to be provisioned in a data center in the United States or in the in EMEA. Those types of things certainly accommodate that. It was already mentioned around the Gov clouds, right? So those are also available as well from a region perspective. And I will pause there for questions. If there are any questions, I'm certainly happy to address any. Okay.
No problem. Well, Ryan, thank you for walking through that security. That was fantastic. Really appreciate that. I think Jason's already had to jump out. I'm still here, and so one of the things I also wanted to show you guys was some of the door prizes, what's available. And I know that Neil and others are working on those names now, but I'll kind of give you a sneak peek. We'll skip over to the Snow Store to be able to see a couple apparel items. And I believe we're going to be giving away 3 different door prizes today. So 2 folks will be able to have access to apparel, and then someone has access to a pair of AirPods. So I'll jump over to the Snow Store to let you guys see what apparel we have. Dun, dun, dun. We have a nice assortment of shirts, jackets, long sleeves, vests, and even for the small, messy one in the family, bibs and onesies, just in case that's needed. A lot more will be coming in soon. Looks like we're having some names. So he's going to post them. I'm going to pick a number between 1 and 156. Let's go with 26 as the first name. We'll go with that. $26. So I'm kind of curious, right? A little informal poll here as we get the other names and numbers picked out. If you could just put in the chat if you have actually ever heard of Snowflake, not so much about our IPO, which a lot of people heard about, but knew anything about the technology prior to this session, be curious to know, because I'm working hard to make sure folks are familiar with us and know what we do. And so with a name like Snowflake, a lot of people don't know what we do. And we'd just love to see who knew ahead of this session. Take a peek here into accessories while we're waiting here from shirts. We can do these as well. The tumblers are nice, the vacuum bottles, the mugs. The charger, actually the power bank, is something that a lot of people have chosen in the past. And a baby blanket, because we got to round out the onesie and the bibs. Okay, I'm going to butcher the name. Coles Bohan. Did I say that completely off? Coles Bohan or Bohan? You are number 26. And so you get to choose an item from the Snow Store. And so, and also you can connect with me afterwards. I can show you this in greater detail as well. You don't have to make your decision now, but if you have an idea of what you'd like, go ahead and do that. And so there, do we need to pick another number? Let's do this. Let's do 112 if we have another number. Thank you guys for hanging with us here. Hope you've enjoyed the session. Hope you've been able to eat something. And it looks like we have our next winner. That would be William Thompson. William Thompson, you're the second winner. You get to choose another apparel item or accessory of your choice from the Snow Store. And then we're going to choose our third person here who's going to get access to a pair of AirPods. And so I'm going to go 97. Let's go number 97 to see who gets the AirPods. Have to be present to win this one. Okay. Alrighty. So I guess probably the closest to number 97 or whoever's around and there that's on. Let's go ahead and do that then. For the AirPods. Megan Evans. Megan Evans, you have just won a luxurious pair of AirPods. One for each ear. Amazing. They come in twos. No, I really appreciate it, Megan. Congratulations. And I will get your contact information to be able to send you out the link that I think we'll probably be able to directly ship them over to you via some Amazon links. So really appreciate it. I'll connect with Coles, with William, and with Megan. Guys, really appreciated you guys taking a look at Snowflake, getting a bit of an understanding of what it is we do, how we're different, and also how we can be used from a security perspective, and also from an enterprise perspective, from all the different types of data and analytics that you're trying to look at, be them customer, be them marketing, be them HR, be it security. and also the unique way that we share data and allow you to connect with your partners, whether it's internally or also externally from a supply chain perspective, and also being able to enrich data sets through our data marketplace, grabbing data sets that have value to you, free of charge, that are analytics ready, with no ETL and no cost. So really appreciate it. Thank you all for the time, and we will send you back to Rocket Secure headquarters as you get ready for the next session. Thank you all very much. Grabbing data sets that have value to you, free of charge, that are analytics ready, with no ETL and no cost. So really appreciate it. Thank you all for the time, and we will send you back to Rocket Secure headquarters as you get ready for the next session. Thank you all very much.
Thank you much, Shannon. We're going to end the morning session. Thank you, Snowflake, for the door prizes as well as the awesome presentation. We're going to end this stream, and we're going to pivot over, and we will be on the afternoon stream. The link for the afternoon stream is in the chat. It's also in the description. It's probably also in the email, and you can also probably just follow the channel on here, the Rocket Secure 2020, if you look that up. So the chat won't be going anywhere. In terms of it's not being deleted or anything, so you can reference this chat or you can reference the link in the description. So